1, 2, 1, 2. I think we are good. It's been a while. Okay. Yeah, what's going on, guys? Jordan, how's it going? Mr. Hammond, what's up, buddy? Whew. It is warm in here. I might need to crack a window, actually. Okay, this does not look too... Okay. Hang on a minute, this looks a bit choppy. Let me try and fix this. 1 second, guys. For some reason, OBS decided to reset its settings. So I'm just going to have a play around, see if I can sort out the choppiness. Change that to medium quality, single pass, profile baseline, GPU. Okay, see if that's any better. How's it going, Cassandra? Evening to you. Why are you watching this? Yeah, it's been a little while since I've done a stream. You know, interestingly, one of the main factors for not streaming has just been getting a decent internet connection up to the workshop. Have a fantastic internet connection to the house. It's really fast, but getting that connection up to the workshop has been a bit tricky. But I have a LAN cable, a 15-meter LAN cable, currently trailing all the way upstairs to the workshop from where the router is. So that's my solution for now. I'm going to get it all hardwired into the walls, but I fancied doing a stream, so I thought I'd get myself a connection up here. Tiger Electronics, yo, how's it going, man? I've missed doing it as well. It's been a while. So let me just crack a window because it is way hotter in here than I expected. Having just put this hat on for the camera. Can I reach it without pulling the camera out of the hat? There we go. Love to see it. Alright, guys. How are we doing? Nice. 30 people watching already. Evening to each and every one of you. Hope you're doing well. Tonight we are going to be working on a bunch of amplifiers, hopefully, provided not a single one takes up the entire stream, because that tends to happen when I plan to get through like 20 amps. I get stuck on the first one. And they're all from one kind of brand manufacturer, and we're just going to see how many we can get through, see if we can find any common causes of failure and stuff like that. I'm going to try and get through as many as I can, and I might do some chatting like here and there, but I'm not going to do too much of a chatty stream this evening. Just going to try and crack on with as much of this stuff as we can. The first amp that we are looking at is this Juice. I love this brand's name because it instantly reminds me of that track back when I was like 13. Oh, how does it start? You wanna get away, let yourself go, it's gonna be okay. I got juice, baby. Yeah, I got juice, baby. Feet so flat, baby, we can fly. Shopping spree, single way, baby, I'm mine. I got juice, baby. So we're gonna look at this Juice. Now this brand makes a bunch of different amplifiers here in the UK. All sorts of full range Class AB, Class D stuff, and this one came in with the issue that it has no output. So apparently, according to the sticker on the box, this one has no output. So let's get the scope cracked on, let's get everything up and running and see if we can find out why this has no output. No output issues, or powering up but no output issues, can be nice and easy to fix, but they can also be a bit of a headache. Let me know how the stream looks, by the way, this evening, guys. I think I'm running my graphics card quite hard, as you can see. if I do make quick movements, it actually gets a bit choppy here. Let me just see if I can fix that real quick. Alright, video output, here we go. I don't know what settings are best to have this on, you know, multi-pass. I assumed I wouldn't want to do multiple passes because that sounds like it would take longer. I think I want a high quality, really. Well, let's just see if that makes a difference, right? Tuning low latency. Let's see if that makes a difference, right? Let's go back to this camera. Make lots of quick movements. Okay, still choppy. Okay, still choppy. So it's not that. That doesn't make a difference. Let's try output. So we're going to go back to high quality. Going to go back to slow because that didn't make a difference either. Constant bitrate. Maybe I want to go for variable bitrate. Bitrate, let's maximum bitrate, let's go for 10, and bitrate, let's stick this at 6. I don't know about profile. I have a feeling like this has something to do with the interleaved, but I'm not sure. Let's see if that's made a difference now. Still choppy as hell when I move my arms around. I remember I had this issue a while ago and I did fix it, but I can't remember what I did to fix it. Bear with me, guys. Let me see. I want to get this stream looking good for you guys, you know. Right, let's try changing this to main. See what that does. Nope, still goes choppy. Well, it goes choppy for me. Like when I move my hands like this, like that on my screen. I don't know if you can see. Like. You can see it's like it's not smooth. Do you know what I mean? It looks like pretty terrible. So I need to sort that out before we get started this evening. All right, so that didn't seem to help. I wonder whether it's because I've got this set to 60 FPS. I do seem to remember that being an issue. I don't think that this PC, whatever graphics card, can deal with 60 frames a second. Right, let's just try changing this to 2 passes quarter resolution and see what that does. No, that's still not happy. Okay. Right. I'm literally just going to press stop stream for 1 second while I change this to 30 frames a second instead of 60. So don't go anywhere, just bear with me. I'm just going to click stop stream. It will freeze for a minute, but then it will come instantly back. You don't have to refresh the page. You don't have to close the video. Just 1 second, it will come. Right, we should now be back. I've changed it to 48 frames a second. Let's see whether that's made any difference. 1 sec. Let's just quickly go back in here. Change this baseline. Single pass. Right, so let's see if 48 frames per second is any better. Oh, that's instantly fixed it. Yeah, instantly fixed. So it doesn't like 60, but 48 is fine. Excellent. Right. Booyah! 30 is a bit choppy. 30 feels a bit like a slideshow now. Everyone's used to high frame rate mobile phone screens and all sorts and gaming. So yeah, we're gonna stick to 48, and that's a good compromise, I think. Right, let's go. Someone said your voice is cutting in and out. Is that just this one person, or is my voice cutting in and out? Right, we're going to hook up the power wires to this because it says that it has no audio, so I just want to make sure that we have rail voltage. We want to make sure that we have auxiliary supply rails generated for the preamplifier circuit. And yeah, this is a 4-channel amplifier, so having no output on all 4 channels, that is not likely to be an issue with each of the channels. That's going to be an issue with part of the circuit that supplies all 4 channels. Matthew, thank you very much for the 5, buddy. I won't lie, I actually missed the RTA mics you used to use. Yes, I agree, but I had to borrow the RTA mics to film Boom or Bust, so they aren't connected. Some of the ambient background noise were kind of immersing. Absolutely. And actually, Matthew, you know what's interesting is I can do that by enabling this camera. This microphone that I'm now using isn't as high clarity from a voice, but it picks up more ambience in the room. You can hear like the soldering iron turn on, the scope settings change, and all sorts of stuff like that. However, when I tested it, this microphone had a clearer easier to understand sound of my voice. Maybe I could merge the two. The problem is, oh wait, I already did it by accident. I was saying this one that I'm currently using has a better clarity in my voice. I could merge the two, but I would need to add a delay to one of them because, as you just heard, because I accidentally forgot to mute the JVC microphone, there is a delay. So yeah, I'm not sure which one to use, but I think this one's probably the best one to use just for my voice. But I agree, the ambient sounds are nice. Ambient. The ambient sounds are nice. What's the RMS of a solid audio F2500D? DJ Nadio, I have a video on that. I benched one. I can't remember off the top of my head what power it did. Off the top of my head, I can't remember. I feel like it might even been over 3K at 0.5, but I can't. No, it's so long ago, I can't remember. But search Bearvid's solid F2500D. I done a bench test on it. So yeah, which microphone do you guys prefer, by the way? So this is microphone 1. Hello, my name is Bearvids. I'm gonna fix a bloody amplifier this evening. And this is microphone 2. Hello, my name is Bearvids. I'm gonna fix a bloody amplifier this evening. So yeah, let me know, 1 or 2. All right, let's get this thing powered up. Power supply on. 12 volts. Let's check a few things then. Let's see whether we have power supply Mosfet switching. Let's turn the scope settings onto the correct mode here. Bandwidth limit. Okay, so we have power supply operation. Looks good. We are sitting at 34 kilohertz on the power supply MOSFETs. That is much faster than a lot of amplifiers that you tend to see. Generally, car amplifier power supply switching power supplies tend to be around 24, 25. So 34 kilohertz, we have a slightly smaller transformer here, so that might be why. Don't know whether that would have been a conscious decision to go to 34 kilohertz rather than the pretty standard sort of 25 kilohertz, but it is a welcome one. Higher frequencies will generally yield better, better use of the transformer. You can get more power through it at a higher frequency for a specific transformer size, and it also means it charges the rail caps a bit more times per second. You know, if it's charging the rail caps each pulse or whatever it is, however many times per second, the higher frequency the transformer oscillates at, the more charges per second you get, more pulses for the capacitor. So that's cool. All right, let's see if we have all of the correct voltages elsewhere on the board. Let's zoom in a little bit on the output section. We need obviously plus minus rail voltage, which we should have considering we have power supply operation. We have plus 26 volts on the positive rail and negative 26 volts on the negative rail, so that's cool. Next easy place to check for auxiliary supply voltages is on the preamplifier op amps. So let's see, we have plus 12 volts auxiliary supply on that op amp and negative 12 volts on there. Okay, so we have all of our auxiliary supply voltages. It's a class AB amplifier. We don't need any other funky voltage supplies like 12 volts reference negative rail or like 5 volts really or anything like that, because we're not supplying drive ICs for class D operation, etc. So that's literally all we need: rail voltage and auxiliary supply plus minus 12. So we're going to inject some RCA signal and see whether this makes us any sound or not. Let's grab an RCA wire here. So we're going to go into channel 1 to start with on here. Now let's have a look at these switches on the side. We want to have full, no high pass filter. We want full range, no bass boost, full range as well on channel 3 or 4. So there's no way on this amplifier to cause the inputs for channel 1 and 2 to also apply to channel 3 and 4. I like it when amplifiers have that. It just means I have to plug less things in on the workbench. But yeah, we're going to need separate RCA for each one to test it. Let's check all of the gains position. That's for the crossover. This is the gain. It's down at minimum. I'm going to increase it to about 1/3. Gain on this one was quite high, up to about 1/3. Okay, cool. There we go. So let's power it up and see if we get any audio. We're looking for audio on channel 1, which is over here. Channel 1. There, the one with the screw missing. Turn my signal generator on. Going to do about 50 hertz, there or thereabouts. Okay, let's call it 60. Huh, okay, well there's some audio. I wonder if all the switches were bad, because I did touch the switch, didn't I, just now? So we have 60 hertz there, so if I put this onto a high pass filter, yep, still have 60 hertz there, which is interesting, because it's a high pass, although the high pass filter does go down to 60, so that's okay. So that's channel 1, so let's check channel 2. Yep, we have audio there as well. Okay, let's go to channel 3. Should be down here. Yep, we have audio, and channel 4. Okay, so we have audio. So this one's fine. It's a good start. Now, these amplifiers have all come from one retailer, if you like. So I don't know because I have never seen it. I don't know the competence level of the testers, the people that test the amplifiers that have been returned. So this one obviously works fine. So possibly when this amplifier was being tested to see if it had a problem or not, whoever was testing it didn't test it properly. Either the RCAs weren't connected right, or something was not done properly when it was being tested to see if it had a problem. So this one's going to go back in the box, and we're going to move on to the next one. But if anything, there's a little easy step-by-step troubleshooting process to check for audio. Check your rails, check your power supply switching, check your auxiliary supply voltages, check your audio. Stephen Nelson, hi Sam, thank you for all the help with the amps. Man, that is no problem at all, it's my pleasure. So just checking the microphone stuff. Most of you guys are saying that you like number 1. A couple of people like number 2 because the background sounds. Well, I could combine the two, but I'd have to calibrate a delay. So if I do this, my voice is all echoey because there's delay. So if we can together calibrate, the correct delay, then I can have both of them enabled. If I go filters, gain. Let's have a look, see if I can calibrate a I think, is it a delay for, I'm not sure which one's behind. Yeah, I'm not sure which microphone is behind in delay, but it would take me too long to figure it out, so I'm not going to bother. Jordan says I have an Alpine Mono. Sorry, an Alpine M. I think that's an MRV M1000 that has a weird issue where it'll only play when I drive a ton of signal into it. But even then, it's very distorted and wrong. So I've come across that kind of weird behavior a few times before, and it can point at different issues. I'm just thinking back to the circuit of that Alpine amplifier, and that to me sounds like a drive circuit issue. So let's say you've got a bit of DC offset, okay, in the kind of preamp and the drive circuit area. then what's going to happen is when your signal is, so if you've got DC offset in the drive circuit area, then when you're playing a signal that's really low, or like sort of a normal level signal, it's gonna, because of the DC offset, it's not going to cross over the threshold of part of the drive circuit to be amplified, and only when you go full chat it will. Or it could be a bad like film capacitor in the preamp circuit, or it could be some bad semiconductor parts in the drive circuitry. So if I was looking at that amplifier on the bench, if I was diagnosing that amplifier, what I would start off by doing is following the audio wave through the amplifier. Okay, so I would start by playing a normal volume sine wave, whereby it doesn't actually produce any sound for you, and then I would follow that through the preamp circuit and just make sure that it makes its way to the Class D drive circuit. And if it does, then I would start looking at the Class D drive circuit and looking for issues around there. If it doesn't make its way through to the Class D drive circuit, then obviously it's a preamp issue, and you can find which of the op amps has probably gone bad. You can look for DC on the op amps. The op amps in the preamp circuit should never have any DC offset on any of the pins other than its VCC supplies, the two supply pins. So if you see like 2 volts or 3 volts or something like that on any of the other pins of the op amp that aren't its supply pins, then an op amp is bad somewhere, it's leaking. Alright, let's move on to the next one. This one here, this next amplifier could also be a no issue. This one could also be fine, just because I'm a bit confused by what it says on the sticker. So this one here, this one says mono only. I don't know if that's a sticker that's telling us what the problem is, but this is a mono amplifier, I think. Is it not? No, this is not a mono amplifier. 1601, I assumed that was a mono. The naming of this amplifier suggests that it would be mono. It's the 1601. Okay, apparently we have 2 channels. This is the IPA 1601, but it's 2 channels. Like, if I was naming this, I would call it the 1602, surely. Why would you call it the 1601 when it's a 2 channel? But there we go. So apparently then, the issue of this one might be that it only works in bridge. It says mono only, so obviously this being a 2-channel amplifier, you can bridge it here on the speaker terminals. So it sounds like that they could only get this amplifier working when it was in bridge mode. So let's take a look inside. Oh, actually no, you know what, just before I break the warranty seal, not that that matters really, because I'm doing warranty repair work, but I'm just curious. I'm going to power it up before I take the back off and just see whether we have a sine wave on both channels or not. Hello David, how's it going, buddy? Hi Sam, are you still busy? What's your turnaround like at the moment? My turnaround at the moment for new repairs is quite busy, it's quite long. 3 to 5 weeks I would say. It's yeah, pretty busy. Imagine they all work. I know some of them won't. I know some of them won't. And you know why some of them won't as well. So we'll get there to the juicy ones. So let's power this bad boy up then. Oh, hang on a minute. Oh yes. I'm just going to power this one up in a sec. And see if this one is doing audio on both channels. So let's grab our RCA signal. Now we're going to need both RCAs because it's a 2-channel amplifier. I want to check the audio on both channels, so let's grab both of those, get them plugged in. line input. Let's check the levels. Gain down at about 1/3, subsonic off. Damn, subsonic was turned up to 50 Hertz. And bass boost was turned up to 12 dB. And low pass filter was turned up to 250 Hertz. What the hell? Alright, actually let's go full range for now. Let's go full range for now and let's see what she's saying. Alright. So we have output on channel 2, the right hand side. And we have output on channel 1, left hand side. So both channels are working. Let's just check that by unplugging one of the RCAs we lose a channel. Yep, the other one still works. Okay, so we do have stereo operation. Let's unplug that one. Yep. Okay, so there could still be a fault, right? Just because we've seen a sine wave on the positive terminals, the positive speaker terminals, could still mean that inside there is a break in the ground trace for the speaker terminals. Because obviously there needs to be a complete circuit. So yes, we're seeing a sine wave on the positives, but if there's a break in the trace or the whatever terminal for the negative terminals, then there won't actually be a potential difference between them. So let's hook up a speaker. I'm going to pull my camera out of my hat in a minute. Can I reach it? Here we go. We have a beautiful little 8-inch Type R. This thing is a freaking beauty. Look at this little thing. Little 8-inch Alpine Type R. It is awesome. I'm just going to hook this up and see if we have output on both channels. So we're going to go into, we're not going to go bridge, we're just going to go into one channel at a time. Because that's what this said. This said that it only worked in mono bridge mode. Which kind of makes me wonder, is there a break in the ground trace for the speaker terminals? So we're going on right channel now. Get this little thing plugged in. There we go. Okay, let's see whether this moves. Sure does. Woo! She's going for it. Alright, so this amp is fine as well. No worries. Might get through these a bit quicker than I thought. But the next one definitely isn't fine. We're going to get into the juicy one next. The next one is definitely not fine. Does that Type R have more oomph behind it than your Elemental Designs 8? Yes, I would probably say it does. Quite a lot more, I would say. This Type R8 is awesome. And if you're thinking, oh hey, Sam, you only tested one of the channels with the sub. Well, we know that we have a sine wave or audio output on both channels, and we now know that we have connection from the negative terminal back to the circuit so that it works. So all we have to do is check continuity between the two negative terminals, And if they have continuity, which they do, that means that the other channel will also work fine. Okay, so let's move on to a juicy one now. Here we go, guys. Can you guess what this one says on the front? Oh yes, this one's going to be fun. Does it smell? Oh yes, love the smell of carbonized board in the morning. Okay, this is the birth sheet, which is stuck to the bottom of the amplifier because someone put some sticky stuff on there. Oh my god, this is like proper stuck. There we go. So this one says that it's produced, well, it didn't produce exactly 1500 watts. Here we go, 1526 this one produced, apparently. I don't know how legit these things are, but has it been actually written in ink? Looks like it might have been. Yeah, that seems like it might be pretty legit. That's cool. So we have a birth sheet. Okay, so this one's smelling bad, so let's crack it open and see what we got. We be burning dollars, turning, but nobody wanna say. Yeah, it's a good shout, whoever called Sean Paul there. Adrian, how's it going? Yes, I'm back with the live stream. If it's not repairable, does it get a death certificate? Love to see it. It's very rare that anything's not repairable, but yeah. That would be a great idea, actually. I should do that. If something's not repairable, if I can't fix something, I should give it a death certificate. That's a really cool idea. There'd be like 1 every 2 years. I don't let things beat me. Even if I end up having the amplifier for 5 years, I don't let it beat me. I think 5 years is the record amount of time that I've had an amplifier for, and then fixed it. Like I'd been stuck with it, like stuck on it, not knowing what was wrong with it, and then eventually worked it out. I think about 5 years. But that wasn't 5 years of continuously working on it. That was like year 1. I don't know what's wrong with this thing. It keeps blowing this part. Put it to one side for 2 years, then try again 2 years later and get a bit further with it, and I'm like, oh, now it kind of works, but this bit overheats or the audio sounds distorted. So I put it on the back burner for another couple of years. Oh man, this stuff's got very, very, very sticky Velcro on the back covering the screw that I need. So just trying to get that off. Come on. There we go. Yeah, exactly, Matthew. The Yamaha SW800. Thanks for the two quid, my friend. I don't think I ever made a video on that. That would have been a fantastic video to make. I fixed a Yamaha YTS something W800, which is like one of their bigger home theater subs. Really old now. Might have been from the early 2000s, not sure when they released those, but really cool sub. Sounds bloody fantastic. It plays down to, I got 25 hertz listenable out of it, like an F3 of like 25 hertz. Really strong at 28. Really cool little sub for music and home theater. And yeah, it was a pain in my butt for a few years. Had loads wrong with it. Alright, what are we saying? Okay, so this one said it had been on fire. Personally, I just see a pretty standard power supply failure, although it does look like it's been on fire. Like, it looks like a fire has existed in this board at some point. So let's get this thing out of the case and get this thing up and running again. Hey, you know what? This actually is a pretty decent little amp. Wow, this actually is not that bad at all. It's using genuine 3205s in the power supply, which is completely unnecessary. Like, it doesn't need to be using 3205s. It could use something a little more cost effective and be exactly the same performance. But you'd love to see it. 3205s in the power supply. We have what appears to be, yeah, we have 3 separate small transformers running the power supply, which is actually beneficial over having one larger transformer. Lots of benefits to that. So that's pretty cool to see. I'll be interested to see what the power supply switching frequency is. Then the output section is a half bridge, and it's using the dual IRS 21844S driver card, which all of the big Koreans use, like the DC Audios and the Sundown and the Ground Zero and all of that jazz. So this is like a little baby Korean half bridge, like pretty solid Korean half bridge. Not too shabby. I'm not hating this thing. The output MOSFETs are IRF 640Ns. Okay, pretty standard procedure. This amp is supposed to do. Oh yeah, this is 1500 watts. This is overkill in the drive circuit department for 1500 watts, I would say. You tend to see this kind of drive circuit running like 36 FDA 24N50s or something like that. Like, not just 12 640Ns. You could drive 12 640Ns with pretty much anything. Alright, are there any screws down the middle of the board to keep this thing nice and secure? Not seeing any at the moment. A little bit of board flex, but it's not too bad. And we'll see why this one failed. Okay, let's get the side. We have Tiffany RCAs as well, nice touch. So on the second hand market, this amplifier might fetch £100. I don't know what these are new actually. If anyone fancies doing a Google for me. In-phase IPA 3001D. I can't remember what these are brand new. Okay, this should start coming out now, if I've not missed any screws anywhere. There, that there. If you try and take one of these apart and it's being a bit, it's not coming out so easily, these FETs, they actually kind of get a bit stuck to this pink thermal pad, so just give them a wiggle just to free them off of the pad. Ah, I think I can see possibly why this one may have failed. I don't know for sure yet until we get underneath it, but see how this Mosfet, the thermal pad doesn't fully clear the FET. So when this is pushed down, we might have a short to the case. Now, we might not as well, because these things are pretty flat. So if you think about this thermal pad, this has a bit of thickness to it, okay? So if this is mostly on the thermal pad and there's a bit of metal overhang, well, there's going to be an air gap between the back of the FET, the metal on the back of the FET, and the case. And this also has the anodizing, the black finish, which isn't in itself conductive. So I don't think that's the problem, but it's not great. That should be, fully over the back of the FET. So these things are 250 new. Okay, yeah. So this will probably fetch £100 on the used market in working condition. Okay, there we go. And we have a couple of little LEDs here that we can detach. Nice. Now we're out of the case. So just to check, doesn't look like we have any arcing on this bit here next to the power supply MOSFET. That wasn't fully covered. Like, that's not ideal, but I don't think that was the cause of failure. Obviously we'll have to, sort that out, put some new pad there, but I don't think that's why it failed. Do a little visual inspection just to make sure there was no bits of metal or solder that were on the thermal pads that caused it to short out through the case. Doesn't look like it. Let's have a look on the back of the PCB at that one MOSFET that was overhanging. As you can see, that thermal paste is where there was a gap, so it wasn't touching the case. So that appears to be fine. Now let's do a continuity test on the output FETs. So we have a blown power supply. Most common reason for that is dead output FETs, because it creates a short on the rails which overloads the power supply. And yes, as oh no, maybe not. Yep, one there. That's a short there. Yeah, we have a dead 640N over here. That's dead short. These ones are alright. So one dead MOSFET, two dead FETs over this side, this one and this one. And then over this side. These ones all appear to be okay. Alright. So let's chop these ones out to start with. Now, this is one interesting thing and could have contributed to why it failed. Let's have a look at these output MOSFETs together, right? These are 640Ns. Now the two ones that failed here, we've got this one on the end here. This one is batch P738P. Don't know if you can see that, how well you can see that. This is batch P738P, okay? This one on the other side is a completely different batch altogether, has completely different font, completely different markings on it. It's really difficult for this camera to make it out, but that is a completely different batch of MOSFET. This one is a P053J. It looks like a different manufacturing run. It's like a completely different font to this end one. So yeah, if we've got MOSFETs there with vastly different VT ratings, turn on threshold ratings, or gate capacitance ratings, or RDS ratings, then you'll have either cross conduction when these MOSFETs turn on at different times. You'll have drive circuit ringing between the varying capacitances on the gate path for each FET, or you'll have, with different RDS values, you'll have some of the MOSFETs doing all the power and the other ones just sitting there chilling doing nothing. So it's really important that you either use the same batch of MOSFET in parallel with others, or if you really can't, then you need to run them on a tester to calibrate them, to make sure that the MOSFETs you're using in parallel all have the same VT, similar CG, and very, very similar RDS. Super important, because although this amplifier has 12 output MOSFETs, if some of them had a considerably lower RDS than others, then it could have really only been like 3 or 4 MOSFETs contributing 90% of the power, and the others were just basically doing nothing. So let's get these dead ones chopped out. The reason we're going to do that is they came out really easy actually as well. I wonder whether that had a bit of vibration damage. One of those legs seemed a bit like weak already. This could have actually been vibration damage. These are coming out mega easy. Okay, these ones all seem okay. Looks like there's maybe a bit of metal fatigue on this one. I don't know how well this camera will make this out. Yeah, you can actually see it there. So you see right there at the bend. See, there's like a kind of slight orangey bit there. That looks like a bit of metal fatigue. Like a bit of, yeah, definitely. Bit of metal fatigue there. Let's have a look on the other side. Seems okay. These ones seem alright. With vibration damage, you can have higher vibrations on one side of the board than the other, so I think that one's alright. So I can't confirm for sure whether it was a vibration damage on this one, but it did feel a bit loose there. I mean, definitely got a bit of metal fatigue on this MOSFET here, so interesting. Alright, let's get this power supply up and running then, and we'll then turn our attention to the output section. So we need to replace all the power supply MOSFETs. Got 4 over this side, 1, 2, 3, 4, 5, 6, 7, 8 over this side. Drive transistors, these are all dead as well. So these down here, the drivers. See if this camera works a bit better. So we've got our drive transistors down here that are all going to need replacing, PNP and NPNs for this bank. And do we have any over this side for this bank, or are they run off the ones from the other side? I think these MOSFETs over here. Here we go. Looks like we have some drivers here that looks like it might be for that bank. So we've got 4 drivers over here for these, and possibly 4 drivers over here for these. Yeah. So that will all need replacing as well. Gate resistors all need changing, but the TL494 should be absolutely fine. All right, let's get to doing some soldering then. Let's cut all these dead FETs out. This is an in-phase IPA 3001D. It is rated for 1500 watts RMS into 1 ohm. Now, are the power supply FETs all the same batch or not? We have Q30D batch there, Q30D, PO280, slightly different batch, but they look like they're from the same kind of production run. They look like they're from the same, you know, factory unit that made them. The font's the same and it's very similar numbers. Hello from Sweden. How's it going, Henrik? Okay, let's get all these FETs out. Guess I can do some Q&A while I'm doing this. Long time no see. How's it going? Yeah, it's going well. Thank you, Matt K. I'm doing all right. Part availability has got a lot better, I found. There's not much recently that I've been unable to get hold of. The biggest one for a while was iOS 2092 drivers. They were like gold dust. Like super hard to get hold of, but I think they're back in stock most places now as far as my suppliers are concerned. iOS 21844S was very difficult to get hold of. Lots of Mosfets couldn't really get, so I was having to, you know, source compatible replacements, random stuff that would work. But most stuff is back now, and yeah, not really having too many problems. Recently got an old US amps that has only positive rail voltage and runs BJTs in the power supply. That's really interesting. Is that a Class D or is that a Class AB? Only uses positive rail. I've never seen a Class AB that only makes use of the positive rail. Class D, yes, seen it loads of times, especially in the newer Brazilians. They only use a single positive rail, and you have half rail DC voltage on the speaker terminals at all times to create a floating, you know, midpoint for the sine wave to oscillate around. But I've never seen it on like a Class AB or anything like that, and I've not really seen it in super old stuff either. So that's pretty interesting. Rob says, I love your live streams, buddy. Thank you very much, Rob. Really appreciate that. It's cool to be back. Class AB from the 80s. Hell, I have not seen that. Stephen says, I can't get 2092s or 2097s. Damn. I'll have to have a look. I haven't had to buy any for a little while. I've got like a decent stock of them. So there could be supply issues that I'm not aware of. Actually, the ones that I know that were really hard, that many people were really struggling to get, was the is it the SI8244BBs that the Taramps uses, and the Banda Viking like 15K, 14K, 10K, that sort of thing. I know that they were really hard to get a hold of recently, but I'm not sure about now. Hello from Vegas. It's hot AF here. It's nice here. It's not too bad. But yeah, I can imagine Vegas being pretty hot right now. Henrik says, I'm planning on building a sub box in my car, but space is limited. Do you have any recommendations for a shallow mount 10-inch sub? Shallow mount 10-inch? Honestly, I think the JL Audio ones are pretty well respected. They actually do sound really quite nice in a tiny box. Alternatively, if you wanted to get a little bit experimental, what you could do is you could use a couple of cheap 10s, like, I don't know, InPhase XT10 or Sony Xplods 10s or something, yeah, something of that caliber, like 300 watts RMS, nice soft suspension, low FS, and run two of them, but in isobaric. Isobaric is brilliant for making tiny spaces come alive. So if you're really limited on space and you want to get super good output, then yeah, isobaric works really nicely. It allows you to halve the amount of required box volume that you would that you'd otherwise need for a single driver. So you don't get twice the output of a single driver, but you get the same kind of output that you would get from one driver in twice the box volume by using 2 drivers and half the box volume. So it's only really beneficial if you're super limited on box volume. If you just want to get loud and you've got a little bit of space to play with, isobaric doesn't really help you. You're better off using that second driver just alongside the main one, like just as a regular like twin sub setup. But if you are super limited on space, then isobaric can do you some good favors. Yeah, the XT subs from InPhase are actually pretty freaking great. InPhase have definitely brought out some nice stuff in later years. Also, another recommendation would be the Bassface Indie S10. That's pretty nice as well. Really, really good value. And if you're going to go isobaric, I recommend doing clamshell isobaric rather than whatever the other versions of isobaric are. Just because it's the same, but clamshell takes up the least amount of space. I know some people like to mount the drivers kind of in the same orientation, like in a cylinder. I don't really understand that. It just kind of wastes a bunch of space inside that. I guess the only benefit to doing that is you get to see the cone of the driver. Like some people just don't like how invert mount looks, and obviously with clamshell isobaric you're always just going to have, it's going to look like, you know, your sub is inverted because you're going to need one mounted on the face of the other, and some people just really don't like how that looks. So I totally get that, I totally understand. In that case, I'm going to run 2 Indie S12s. Yeah, I've actually got, I've actually had a Bassface Indie S12 prototype running in my Proton for like 2 or 3 years now. Honestly, sounds brilliant. Like, my Proton is an SQ setup, so I'm barely tickling it on 500 watts RMS from an Alpine MRVM 500. So it's just getting tickled. It's in a little L-ported box at 33 Hertz, there or thereabouts. Sounds awesome alongside the rest of the setup. So yeah, I would recommend. They didn't change much between the prototype and the actual release version. So but if you're looking for something a little bit more powerful, it's still hard to beat the InPhase power drives, man. The InPhase power drives are freaking awesome for the money. The InPhase power drives are the previous generation of Digital Design's Redline. So the Digital Design's Redline subs with the red stitching are absolutely exactly the same in every way, shape and form as the InPhase power drives, exactly the same sub, and they're super good value for money. The new DB Audio T-Rex subs are in a similar vein. They're very similar kind of setup in their motor and coils and stuff like that to the InPhase power drives, so they're pretty good as well. Do you consider rear basket construction when choosing the best subwoofer for rear cone base wavelength? Like the MAX Cab Ultra 18 Dayton Ultramax subs. The rear basket construction. So if the basket at the rear is too constricting, then it can actually act a bit like an enclosure inside the basket itself. Obviously it won't be anything useful, but what it will do is it will create a kind of oscillation, or it will create an issue. You'll create some back pressure to the cone that is unnecessary, that's actually hindering the cone's movement, which you don't want. But honestly, I haven't really seen any drivers that would have big issues with that in recent times. It's definitely something to consider if you were designing a sub, keeping the basket as open as possible. But yeah, not really come across any that I would say have a big issue with that in recent times. It's going to be more of an issue with smaller subs. Like if you've got a little 6.5 inch that's really beefy with a massive coil and it needs like a relatively stout basket because it's you know, heavy magnet and stuff like that. I can see it possibly being an issue there if it's very constricting and there's not much space for airflow out of the basket. Gidria says, you've been on holiday? No, I have not been on holiday. I've been working my ass off. The reason there's not been so many lives is because I've been so busy. Live streams take longer than just repairing stuff normally because I'm chatting to you guys. So, but I'll tell you what, guys, I'll tell you what I have been doing. Obviously, I've not been doing super loads of videos on YouTube. And I've not been doing any live streams. But what I have been doing, because it's very quick for me to do, is I have been uploading on TikTok. It makes me feel a little bit sick to say those words, but yeah, it's actually been going really well. I have avoided that absolute cesspit of a platform for as long as I can, but although 99% of the content on that platform is utter garbage, I am putting out really cool little repair snippets on there between like 2 and 6 minutes long, and they're really snappy and they're really fast paced and they're really cool. And the audience, I mean, obviously, like, although most of the content on that platform is garbage, there are real people that watch TikToks, and there are engineers that watch TikToks, and there are, you know, real cool people. So I've actually got a really good response to my amplifier repair videos on TikTok. Like, I'm getting like hundreds of thousands of views on there, whereas my YouTube barely get any. So yeah, I'm quite keen. I am doing quite a lot of content on TikTok now. So even if you're not on the app yet, even if you just download it just to watch my stuff and just close the app whenever it goes to your For You page, that's cool. That's fine. There is some cool stuff on there, but generally what I would recommend you do, if you're gonna download TikTok, if you're gonna give it a go, don't just scroll on there, man. It is just an absolute cesspit of the most brain dead nonsense garbage you'll ever consider could exist on a social media platform. It is nonsense. But if you go there with a specific creator in mind, or you're looking for a specific type of content, then it can be really cool. Exactly, yes. I think if I wasn't uploading to TikTok, I wouldn't have it on my phone. I don't watch anything on there. I close the app immediately as soon as I'm done uploading or done looking at comments. I just literally use it to upload and read comments. Ah, found something else on this amplifier, guys. You'll be interested to see. I was talking earlier about vibration damage, wasn't I? So we're gonna see a little more of that in a second. This wire is driving me nuts, actually. I'm not sure what to do about it. I need to like tape it to my hat. I did used to have it taped to my hat, but it would always come off. Let me see if I can quickly tape it back onto my hat. Need some tester tape. There we go. Should do. Straight up kicking nuts. Hey, did you get a chance to look further into the Mosfet safe operating area since I pointed out on the datasheet? Absolutely, man. Yes, that is. Tell you what, your suggestion there to look at that graph on the datasheet has been fantastic. Thank you so much, Straight up kicking the nuts. Honestly, I'd always glossed over those kind of graphs. The ones that I would tend to look at would be things related to temperature or things related to how the RDS changes with the amount of voltage on the gate versus temperature, all sorts of things like that. But I'd not really considered the graph that's called safe operational range. I've never really considered that and not really looked at it in great detail. And since doing so, I have gone over and re-evaluated some of the Mosfet choices, or when I've been looking at suitable replacements, I use that graph every single time. So that has honestly changed my workflow when it comes to picking out suitable replacement MOSFET. So thank you very much, Straight Up Kicking the Nuts, for that little tip there. It's been really, really cool. So I'm just currently removing the gate resistors on this this amplifier. So this amplifier has a power supply section failure and an output section failure. It's basically it's a full rebuild, this one. And the gate resistors are all cooked up as a result of the failure. So just taking these out. Sam, after you fix, can you do a dyno run and see if it lives up to the numbers claimed? I don't have a power supply hooked up right now that can run this amplifier to full potential. I've only got the bench supply, which does 20 amps. So no, I can't do a dyno run on this amp today, unfortunately, buddy. Yeah, no, it really did help, Straight Up. Thank you very much for the tip, man. I really appreciate that, as always. We're all here to help each other out, innit? So right, drivers next. I'm going to get these drive transistors out because they will most likely all be toast. So we've got 4 in the middle of the board here, and there's another 4 on the side near to where the MOSFETs are. Drive transistors, not super fussy. For power supply drive transistors, because power supply switching is relatively slow, between 20 and 40 kilohertz, as long as you are using relatively quickish transistors, it should be fine. BD139s are pretty like universal replacements for the NPN transistor. For the PNP, I tend to use 2SB772s, or recently I've been using something else which I can't remember the exact name of, but we'll see it in a minute when I get it out of the drawer. Have a question. I have a DB3515. Do you mean a DD? Digital Designs 3515? What's your question? Okay, that's the drivers there, and the other drivers are down here. The telltale sign that they're down here is the burnt PCB on the underside where the drivers are. Now, the reason the drivers get cooked is because when the MOSFET's short, they short obviously 12 volts through to the gate path as well as ground. So 12 volts makes its way down the gate path, and then you have these PNP drive transistors, and the 12 volts goes through them to ground, giving them a nice cook on the way. There was some vibration problems. Yeah, I haven't actually got to that yet. Well, I shall show the other vibration damage that I've just seen that may or may not have contributed. Yeah, of course I've heard of DLS, Henrik. I've repaired quite a few DLS amps. Pretty nice. What's your take on the new Edge subs and stuff? Not a massive fan. Not a massive fan. The subs don't seem to have the best build quality. Seen plenty with offset coils or sort of like issues with the spiders, and they seem very inefficient. They seem very like they need like a bunch of power to really start getting going, and they get quite hot quite quickly as well. So yeah, not a huge fan of the subs. The amplifiers, the new Edge amplifiers are the Chinese clones of the sound digital circuit, and I like the idea. They're nice and efficient. They're using modern, Mosfet technology and modern FETs, nice low RDS FETs and drive circuits and stuff like that. But the build quality doesn't seem to be there, and also because they're Chinese clones, they're not really optimized. So they've just kind of cloned the circuit, basic circuit as a whole, and they've not really kind of optimized each one of the amplifiers for its specific power. They've just kind of like scaled the amplifiers up and down. And you tend to see quite a lot of them fail, so I'm not a huge fan of them, but they are pretty cheap and they're not bad for the money. Build quality of DLS. Every one of the DLS amplifiers that I have seen and repaired has had a pretty outstanding assembly quality, build quality, traces, like the way that the boards are secured down. Yeah, really freaking nice, really fantastic. Yeah, build quality on those. Never seen any of them fail due to like vibration or anything like that. Pioneer, Car Audio Center told me that Pioneer copied their design with the 7901. Well, that's not true. That's as much as I'll say. Oh, Def Bonts DB3515. I don't personally have much experience with Def Bonts subs, so I'm not sure I can give you the best advice on that. But Def Bonts subs seem pretty stout. They're not super engineered. Like Def Bonts haven't really done a huge like proper engineering R&D on the subs. They kind of remind me of like Alibaba subs, but like a bit better, like a bit of thought and a bit of change has gone into them. Really strong motors, like the actual magnets, the motors on those subs are freaking monstrous. But to keep the assembly cheap enough, costs down, they have pretty massive coil gaps. So all of that motor force isn't really being taken advantage of in actually being used to drive the coil, you know, to create a really strong flux environment around the coil. However, the reason I say however is because that's not always super desirable. Okay, the kinds of subs that have a extremely strong motor coil relationship and really tight coil gaps are like the old DDs, like the old 3550, the 9500 series, or the 9917s, like the, you know, old school DD subs. Mega tight coil gaps, making full use of all of that flux. And yeah, the BL product will be monstrously high. However, that kind of motor coil relationship isn't actually ideal for playing like really low frequencies, like 20 to 33. It's not really the best for that. For playing super low frequencies, you want a slightly looser motor coil relationship, like slightly bigger coil gaps and stuff like that. So it actually kind of works in their benefit in a way. Really big motor to get some good magnetic strength, but then a slightly looser coil motor relationship can help the sub play nice and low, nice and smooth. Because the older DD subs, although they were fantastically efficient and monstrously loud on the higher frequencies like 35, 40, 50, 60 hertz, etc., they weren't the best at playing the lower stuff. And part of that, there's lots of reasons for that, but part of that was to do with the insanely strong motor force that the coil actually has access to. There's one drive transistor here that's going to be a bit of a pain to replace because it's covered in epoxy. So we'll see how that goes. Well, I'm going to have to clear some epoxy off there first to get that one out, I think. Okay, so that is officially all of the drive transistors, gates and power supply FETs out. So I'm just going to go to the top of the board now. We're going to have a look, and I'm just going to need to remove this epoxy here because it is completely covering the area that I need to get the new drive transistor in. I think the best way to remove this epoxy is going to be a bit of heat. So I'm going to turn the hot air gun on. Although it seems to be coming off relatively easy, just like this. I might turn that off again. Come on, off you come. There we go. There we go. That's going to need a little bit more clearing now, then we're good. Okay, so new Mosfets. Actually, before we put the FETs in, I'm just going to suck all of the solder from the gate resistor holes. Something that we should do. Okay, that should be good to go. What 12-inch sub has lots of motor force, like we was talking about with the tight gap like the old DD? I've not really come across a bunch of modern subs that have the same kind of characteristics that the old DDs had, if I'm perfectly honest. The only ones I can really think of that would like have a nice, that are a good mix, like good sort of midpoint between the two. I really like FI audio drivers. I think they are really well engineered, really nice drivers. So if you're looking for a really musical 12 that could play both highs and lows with no issues, nice and efficient, nice engineering, then yeah, probably an FI sub of some kind. Type R subs do have a pretty tight gap. Yeah, that's right, actually. That's very true. Type R are quite well engineered and they're very well assembled. Eberg, how's it going, buddy? Good to see you're still kicking. The heat wave in the States is keeping us repair techs busy. I bet you're getting a bunch of amplifiers failed from the higher temperatures for sure. Semiconductors hate that shiz, hey? Right, so what we can do first? Drive transistors or FETs? I think we're going to do drive transistors first. So let's grab the PNPs. Now the replacement PNP drive transistors that I like to use at the moment are BD676. I've also used two SB772s in the past as well. So I can't remember which ones were the PNP FETs. Really easy to find out. Just take your multimeter, check between Mosfet source on the power supply and the middle leg of the drivers, and the ones that have continuity will be a PNP. So that's an NPN, that one there. And this one here is going to be a PNP, so it should just be these two back ones. So let's shove our PNPs in there. And then over this side, it's the ones closest to the transformers that are the PNPs. Here it now says, what's the difference in Taramp schematic 1 ohm stable or 0.5 ohm stable at the same rating, example 12K? There's actually quite a lot of differences. Although it's the same board layout, there are actually quite a lot of different components. So as someone else in the chat stated, Eberg said, obviously the rail voltage will be different. So for 12k at 0.5, you need drastically less rail voltage than you would need for 12k at 1 ohm. So because you're going to have a lower rail voltage, that's going to mean you're going to have different transformers. So the actual transformers, like these things on the power supply, will be wound differently. They'll have less secondaries or whatever, but yeah, they'll be wound differently to give you lower voltage on the output. Secondly, you're going to have different spec rail capacitors. You're going to have different spec output MOSFETs. You're going to have probably you might have different spec inductors in the output section as well, possibly. You're going to have different components in the protection circuits. If it has a snubber resistor, not a snubber resistor, sorry, a shunt resistor used for current sensing, then that will be different. You're going to have different resistor values for detection of rail voltage to see how high the rail voltage is for the MCU to detect. What else? What other things will be different? I think now the capacitors in the filter network might be different. Don't think any of the drive circuit components would be that different, really. That's possibly getting on for almost it. The Type X, the Alpine Type X subs, I think suffered from mechanical failure. The tinsel leads, the connections to the coils were really weak, and I think they snapped really easily. So I think that's the most common issue with the Type X subs. What's your opinion on the Smart 8? Will you be doing a comparison? I would freaking love to do a video on the Taramp Smart 8, but I don't have one yet. I haven't seen one yet. I would love Taramps obviously to send one over for a look. However, given my recent review on the head unit, the amp player that I did, I don't know if they'll be too keen to send something over. I know they might do. I think they value a honest review. I've spoken to the guys at Taramps, so Taramps sent the head unit over for review to me. They sent it over to me for review for free. I didn't pay for it. However, despite that, obviously, I gave them a relatively negative feeling review. If you've watched my video on the Taramps head unit, the overall opinion is that it's not great. It has potential, but in its current form, I wouldn't really recommend it. So everyone should know by now that I review things as they are. Doesn't matter if the company has sent something for free, doesn't matter if they have paid me to review it, I will tell it how it is. But I have done pretty glowing reviews in the past for the Smart 5, which I genuinely think is absolutely fantastic. But I didn't say that it was perfect. I pointed out potential issues with it in the review, but overall it was a pretty good review, and I think that my video of the Smart 5 probably sold quite a lot of them, considering how many views it's got, and considering there's not really any other technical deep dive analysis of the amplifiers on YouTube. I would say that video probably sold quite a few of them, and also the Smart 3s. I always push the Smart 3s as well. So I would like to think that Taramps would be happy to send me over a Smart 8. I would love to do a review, but I think I've kind of missed the boat a little bit with it. It's been released now. Lots of them are, being sold, so it would have been cool to do one at release. But I'd still love to do one in hindsight. Have you ever had an amplifier with a 9-volt protection circuit? What do you mean? A amplifier that protects at 9 volts? Yeah, most of them protect around that voltage. A lot of the Koreans have a little jumper on the power supply drive circuit board that you can switch to have it protect at 9 volts, or to have it try and continue playing under 9 volts. But most amplifiers won't be too happy playing under 9 volts, and they'll go into protect. Either because the protection circuit kicks in at that point, or because under 9 volts the supply voltages just aren't high enough to maintain operation of the drive circuit and stuff like that. What do you think of Alibaba subs? I have no idea. I've never ordered a sub from Alibaba, so I can't really comment on what they're like. Right, new gate resistors are going in now. What do you think of the Tyrant Smart 3 bass? Got one coming to you. Would be cool if you were able to repair it on stream. Yeah, everything I've seen of the Smart 3 and the Smart 3 bass has been freaking awesome. Like, obviously, you will get ones that fail, as with any amplifier, especially with a 3,000 watt RMS amplifier that is sold pretty cheap. You're going to get lots of people buying them and don't necessarily have, you know, the best experience, the most experience, so there might be a lot more user error with something like that. But yeah, the Smart 3 and the Smart 3 bass has really impressed me. I think it's a fantastic amplifier for the money. It's almost unbeatable in its price range. Like, gives you 3K between 1 and 2 ohms, or 0.5 and 2 ohms for the base model. It's like an absolute no-brainer for the price. Yes, definitely. So yeah, if you're not sure about that jumper, what that does is with the jumper switch to the on position, that will allow the protection circuit to kick in when 9 volts is reached. If you flick that to the off position, then the amplifier will still continue trying to play under 9 volts. And depending on the amplifier, the rail voltages, etc., the tolerances of the drive circuit and stuff, it might continue playing down to 8 volts, maybe even 7 volts, but at some point the auxiliary supply voltages will reach the threshold that the components just don't, you know, they don't work anymore, and it will turn off, or it might even fail. The amplifier might blow, because if the drive circuit turns off in a kind of like unplanned way, it can actually cause the output MOSFETs to fail. Yeah, I'd be interested to do a review of an Alibaba sub, but let's be honest, I'm not really going to be willing to pay for one. Alibaba only really works if you're buying like hundreds of them anyway, otherwise it's not that cheap. So if one of the sellers on Alibaba wanted to send one to me, that would be okay. Do a pretty in-depth review of a sub. But yeah, not really probably going to buy one myself to review. What's the lowest voltage you've ever seen an amp run at? You know, that's a great question. Like, I've never really tried. Like, I've never really, like, purposefully thought, oh, let's just see what lowest voltage this amp runs at. Like, but, like, I'm pretty sure I've seen some of the Koreans and stuff run down to, like, 7 volts. We can try it with this amp I'm fixing here. Once we've fixed it, I'll drop the power supply down as low as it will go until it protects. I don't know if this amp has a low voltage protect. It probably does actually. This amplifier probably has a fixed low voltage protection mode, and I could disable it, but I really can't be asked. It's like, you know, extra work. But if any of these other amplifiers have a switch for it to turn it off, like some of the Koreans do, then yeah, let's have a look. Reset. Hey dude, I got that head unit fitted and set up with an amp. I sent you a video on Messenger. Okay, man, I'll check it out. Thanks. David says, your knowledge is insane. Thank you. I don't believe that myself, but every day's a school day, always learning. There's plenty that I need to learn still. But trying to get an Alpine V12 MRV F340 fixed. Yeah, David, if you're in the UK, if you're in the United Kingdom, then absolutely send it my way. Almost every single time, a repair is cheaper than a replacement. Almost every time. So shoot me a message on my BearVids Facebook page, facebook.com/BearVids, and yeah, let me know what's up with it. If you're in the UK, I'll have a look and probably get it fixed for you. yeah, so once this amp's fixed, I'll run it down and just see what voltage the protection circuit kicks in at. Be really interesting to see. But I'm pretty sure that some amplifiers, I'll tell you what actually, I'll tell you something. The Brazilian amplifiers have the best potential to run down to stupidly low voltages. And the reason for that is that all of the drive circuitry and control circuitry and everything in the Brazilian amplifiers isn't referenced to the transformer. So it's not the kind of auxiliary supply voltages for all of the control circuitry, preamp, drive circuits isn't run off of an auxiliary tap on the transformer. So it isn't directly tied to, well, it is directly tied to the supply voltage, but not in such a drastic way. So let's say, for example, that the MCU needs 5 volts to operate. So that uses a little boost converter, a little buck converter from 12 volts on the power terminal. Buck converts it down to about 5 volts for the MCU. The preamplifier op amps they use a sort of floating midpoint, and they use, like, the op amps can run on as little as like 3 volts, I think, plus minus. So you could run that down to sort of like 5 or 6 volts, and they'd be all right. The driver on the output side needs about 12 volts, but that is, I think that might even be boost converted or something like. I'm trying to think back to the Sound Digital one. Uses buck converter. Yeah, I think it boost converts it up to like 15 volts. So it might even continue to be able to boost it up to operational range even with like as little as 5 or 6 volts on the terminals. So the only reason that the Brazilian amps protect at a certain voltage is because they're programmed to. They listen to the rail voltage. When it drops below a certain threshold, it protects. But if you were to disable that protection, then you could run the amplifier possibly on stupidly low voltages, and it might be okay. Be a really cool little experiment to do, actually, wouldn't it? And I tell you what would be an even cooler thing, which I actually do all the time when I repair. Sometimes when I repair the really big Brazilian amplifiers, I will actually inject my own rail voltage, right? So because the control circuitry and everything uses a different sort of, it's not referenced to the rail voltage. So what you can do is you can actually inject your own supply for the control circuitry, and that doesn't require barely any current. So you could like run a little 12 volt power adapter that outputs like 1 amp at 12 volts, could run all of the drive circuitry, control circuitry, MCU, power supply, PWM generation, everything like that. And then once all of that is up and running with a reliable 12 volt supply, you can start at 0 volts on the power terminals, and you can start increasing it slowly, 1 volt, 2 volt, 3 volts, and that will then in turn start building the rails like at a ratio. So you could start, like, let's say you had a 12,000 watt Brazilian amplifier. If you injected a supply for the control circuitry, then you could start at like 1 volt of power supply input power, and that would maybe convert to a rail voltage that would allow maybe an 800 watt output. Then 2 volts, that would give you maybe like 2000 watts output. Then like 4 volts would give you like 4K, etc. You could ramp it up like that, and that's actually one way that you could use these amplifiers indoors off of a mains transformer or something like that. You could rectify some AC from your mains, run the control circuitry on a little 12 volt adapter, and then you could just run whatever rail voltage you wanted up to the limit of the components in the amplifier. And that's a really cool, easy way to run these amps indoors without having to get a high current 12 volt power supply. Okay, so new drivers are fitted, new gate resistors are fitted. I think now it's time to power it up and just make sure we have good PWM at the Mosfet pads before we fit the FETs. Diesel says, in fairness, TikTok is how I found you, and then I found your YouTube channel. Nice to see fellow basshead and electronics tech. Ah, cool, man. That's really cool to see someone that's found me from TikTok and come through to the YouTube. I know that the conversion rate from TikTok to YouTube is very low. So Diesel, you are a unicorn. Thank you very much for coming all the way from TikTok and staying involved on the YouTube channel. That's freaking awesome. How do you feel about the DS18 Hooligan KO5Ks? The KO5Ks, I think, are the same. I need to check a picture, but I remember when I did the video of the Digital Designs M4000, and I think in that video I said that it was the same circuit as the DS18 KO something something. So I think if that's the same circuit as the Digital Designs MA 4000, 8000, etc., then yeah, pretty good. Not bad at all. Kind of older circuit design, but very good build. We'll be doing an enclosure series again, possibly. Not sure what's happening with Boom or Bust yet. I would like to carry it on, but it was just taking up so much time. And I wasn't getting... Honestly, Boom or Bust didn't really get the views that I thought it would. So it was actually not really cost effective for me to make the episodes. When it came, you know, all of the printer filament and the energy used printing it, and it usually took like a day or 2 days to create each episode. And it wasn't really, you know, wasn't really worth it. Alright, let's see whether we have good PWM on the gate pads. So we're going to go ahead and probe the power supply Mosfet gate pads. We've fitted new drivers and new gate resistors, so provided the TL494 is okay, which it almost always is, we should have good PWM over here on these. Got a lot of noise on the scope. I don't think this this oscilloscope probe is actually very happy. I think it's got a bit of a bad wire, because I get a lot of noise with this probe but not much with the other probes, so I'm just going to have to ignore that for now. Ignore the noise on the scope screen, we'll deal with that. So let's hit the remote and we should see, there we go, some PWM. Okay, we have a nice high frequency, 38 kilohertz. Love to see it. Rather than just copying every other PCB design of this style, the factory that's made this amplifier for in-phase has actually thought, hang on a minute, we have nice small transformers here. They can run at a much higher frequency to get their optimal efficiency and power throughput at a higher frequency. I imagine that they could probably run quite a lot higher than 38 kilohertz to get even more power throughput and efficiency, but it's better than being at 25, so that's good to see. That bank looks nice and clean. Let's move along and check the other bank. So we got 5.5 volts RMS on that bank, 5.5 there. That's looking good. That's 5.3. That's a touch lower. Got 5.5 there. Just have a quick look on here. Okay, let's pause the screen. Let's go along to our next bank here. It's a touch lower. Okay, that's something to bear in mind. We've only got 0.2 of a volt difference between these banks, but, and that was 5.3, 5.3, 5.5. So we got a slight bit of difference there between the voltages here on the push and the pull bank. Yeah, you can see here that this bank here, these two FETs are going to be the push, and these two FETs are going to be the pull. So the drive waves on this bank are going to be 180 degrees out of phase with the drive waves on this bank, push-pull. So these two are 5.3 volts and these two are 5.5 volts. Not usually a good sign to see a bit of variance in that, but we'll get to that later. We'll have a look and see why that might be. But it's not necessarily the end of the world, but it's just not really a great sign. Let's check the FETs over here. Now these are run on different drivers. We've got 5.5 on that bank and 5.7. Okay. So yeah, there's a fair bit of variance there. Now, On this amplifier, I've just had a look at the circuit here. On this amplifier, the thing that sets or calibrates the voltage there is actually a couple of Xenodiodes. See, we've got D4 here. I'm pretty sure that's going to be a Xenodiode. D5. And you got D2 and D3 over here. So these diodes are going to be making sure that they're basically going to be clamping the voltage of that drive wave. And now if any of those diodes are damaged, or if their tolerances are just a bit whack, you know, if they're like cheap diodes and their like tolerances are kind of whack, then you might see this variance in the drive voltage. 0.2 of a volt here or there isn't the end of the world, but I'm very used to seeing them all being identical. So I just want to go ahead and check with the multimeter these diodes here. I usually have a multimeter camera set up, which I actually do, I just haven't plugged it in. So let me just plug in my multimeter cam for you real quick, and then you can see what I see. Let's get that plugged in. Yeah, it could be a pull down resistor. But I think looking at this, it's more likely to be the Xenodiodes that are just the tolerances are a bit wacky here. So let me just get my multimeter camera here up and running for you so you can see the camera. Okay, there we go. It's a little bit out of whack, so let's move that up a little bit there. A little bit closer. Yeah, that'll do for today. You can see that, can't you? So, let's check this first one. So we have 480 in diode mode, one way round, and let's flip the probe, check the other way. Oh, 484. Seeing the same value both directions on a diode is a bit uncommon. We could be reading other things in the circuit, but that's very, very similar. Let's check this next one here, D5. 478, that's a bit of a different, it's pretty similar value, but, and the other way around, 480. Okay, maybe we're just reading other stuff in the circuit. Let's check D3, 479, and 484. And this last one, don't know if I can get under the epoxy there. 484, 49. So the values there are a little bit different between these diodes. So I'm going to fit some FETs and just see how they run. I'm just going to sort of see how they're driven. It's probably fine. Having a little bit of variance between the gate drive voltages, like that 0.2 of a volt, like I say, it's not the end of the world. It's not a super big issue. I'm just very used to seeing them all being absolutely identical. So we're going to fit some FETs and just see how it affects the power supply operation, if at all. It might not affect it at all, but fitting the FETs will definitely show up if there is a problem. So let's get some FETs in and see what it looks like. We're going to need to bend these down. So these FETs go in like this, and they're bent down pretty close to the top of their legs here to clamp to the heatsink. There we go. I've got two different batches of Mosfets in this drawer, so I want to make sure that I grab the same batch for the entirety of this amplifier. That hole needs a bit more solder sucking, so we'll do that one in a bit. Okay, so these last two just need a little bit more sucking on the holes. I'm looking for ones that are the same batch. I've got two different batches in here, 702s and 615s. Would it just be bad luck that I just happen to have run out of 615 batches and I've got three left that I need? Let's check the other drawer. There we go, here's some more. I have actually labelled some of my drawers, actually. Yes, look, have a look. Here we go. I can't really see. Let me just take the old hat off. I have started to label some of my drawers. I've not done all of them yet, but I have started labelling some of them, as you can see. Some of them up here are labelled as well. What's going on with the yellow car? There has been a relatively recent video with the yellow car in it, which is called something like Come For A Drive. Yeah, that's my Proton, man. That's my daily drive with the T-line door cards. I'm running a prototype bass face Indie S12 in a 33Hz aero ported, slot ported box, L ported box. And yeah. It is one of the nicest vehicle sound systems I've ever heard, and I've heard like quite a lot of like SQ sound systems and stuff like that, and there's just something about the Proton system with the T-line door cards and the A-series DD speakers and the A-pillars and the Genesis 8-channel Class A, Class AB dual mono amplifier. It just sounds freaking amazing. It's not necessarily the most like I wouldn't compare it to studio monitors in terms of its like transparency to exactly what the signal is, but it is warm. It is very exciting to listen to. When you listen to a song in the Proton, it freaking comes alive. It is really exciting to listen to. I have obviously the Martin Logans in the living room, the electrostatics, which sound unbelievable. But although they definitely have much more vocal clarity and like they sound much more realistic and like you really feel like you're there listening to live performance, the listening experience in the Proton is just so exciting and so fun sounding. It's an incredible system to listen to. Like I popped out yesterday. I went out to the shop to pick up an order, and I was listening to a song on the way home, and I pull up in my driveway and I sat on my driveway for like 15 minutes or something, just listening to the same song on repeat, just because it sounded so freaking good. That's what it's all about, man. Like you know you've done your sound system right, and you've not necessarily accurately correct, like, but you know when you have done your sound system right enough that you enjoy it so much that you pull up on your drive and you don't want to get out of your car and you just keep listening to the next track and you're just like, fuck, this sounds good, man, bloody hell, and you're just like, wow, and you just don't want to get out of your car. That's when you know that you've done the system right for you. Did you get the heater core fixed? No, I bypassed it for the time being because it's summer. The heater core requires a dash out repair, so that's not going to happen anytime soon because I don't have time for that. But I have bypassed it, so it works fine. The car works fine. Just don't have any heat in the cabin, which is fine at this time of year. It's tuned to the driver's seat, yeah, absolutely. You get a beautiful image in, on the center of the dash from the driver's seat, and there's a second calibration on the head unit for the time alignment for the passenger seat as well, so I can switch it over to the passenger. But it's mostly set up for the driver's side, like all of the EQ and stuff is all set up for driver's side listening. We'll be doing another round to see if people can tell the difference between half and full bridge. That's not the video that I made. Cargo, I'm a little bit sad that you worded your question in that way. Because being full bridge or half bridge has nothing to do with how an amplifier sounds. And I repeat that all the time. I even made a video specifically about it. So I'm a little bit sad that you worded it in that way. The video that I did on the Teraamps versus the... Actually, no, both of those amplifiers were full bridge anyway. The JBL Crown and the Teraamps video that I did, the comparison wasn't about full bridge versus half bridge. It was about a amplifier that people hold in high regard for its sound quality and an amplifier that people don't hold in high regard for its sound quality. Both of them are Class D, both of them are full bridge. But I would like to do a video like that in a similar vein with Class D versus Class AB, but I just don't know when I'm going to get the time to do that, so we'll see. After you've repaired an amp and you're about to turn it on, do you get a little bit nervous still? Depends on the amplifier. The power supply that I use is current limited, so I don't get nervous about powering it up like that. The nervousness comes from when I've got an amplifier that has a really high rail voltage, very powerful amplifier like 5,000 watts RMS or more in half bridge format, because even though I can have my power supply current limited down very low, there is a lot of energy stored in the rail capacitors. So if an output MOSFET fails, then all of that energy in the output capacitors, in the rail capacitors, gets dumped into the FETs and they explode very violently, very loud, lots of shrapnel flying past my face. It is not pleasant. So with the bigger Koreans, I definitely do. I have my safety glasses on. I have these glasses on, and I have my hands over my ears because it's very loud if they do pop. I power it up, and I stand to the side, and I monitor the drive wave on the output side, go from 9 volts, 10, 11, 12, 13, 14 on the power supply, and I just wait for it to blow up, and most of the time it doesn't, but on the odd occasion it does, because a component was weakened and was running fine at lower voltages, but just fails as soon as you turn the voltage up. So yeah. What's the scariest thing that ever happened when repairing an amp? That's a freaking great question, man. I'm loving your guys' questions this evening. I accidentally touched, I think it was 350 volts DC across my little finger one time. That was interesting. That felt kind of funny. But the scariest thing was probably, I can think of 2 occasions. One time I've actually got a video of it. Do you want to see? Here we go. I have actually got it queued up. Are you ready? This was one of the scariest things that ever happened. Korean 12K, 16 volts on the power supply. The rail voltage was something like 480 volts potential between the rails. This is what happened. It doesn't look like a lot on camera, especially with the audio, but that sound was so violent, like you feel the shockwave through your body. Mosfet shrapnel going everywhere, absolutely violent. Hate it when that happens. The cause of that failure was either a dodgy batch of output drive ICs or a dodgy batch of bootstrap diodes. Not sure which, but either that, or there was one time when I was just starting out, probably in my first year of amplifier repair, and my probe accidentally slipped while I was working on a Taramps HD10K 2 ohm version. Very high rail voltage. I was probing the output MOSFET drive wave, probe slipped, and I shorted rail to ground, and the oscilloscope probe, the little tip, just freaking obliterated. Massive bang, big spark as bright as the sun. My ears were like dee because it was so loud. But I've not really had too many huge disasters, to be honest. Like, yeah, you always get a couple here and there, but nothing really super bad. I never did get around to making a part 3 for the audio pipe mod. I still have it here. I think I just got a bit of ADHD block. So like, I got so far, like, one of the problems of ADHD is you struggle to finish anything. Like, I really struggle to fully finish anything. Like painting my kitchen. Like there's bits of it that are still not quite painted, like little corners and stuff that aren't quite finished. Doing the floor in the kitchen, like it's pretty much done, but like some of the edge bits I needed to like cut little strips for that I haven't done. It's sometimes really hard. Like you feel physically unable to finish something, and you have like it's really weird. I can always finish things for other people though, like amplifier repairs. Yeah, fuck it, I'll do it. Anything for other people, I am super motivated and I will finish it and I will make a fucking great job of it. But anything for myself, sometimes I hit a brick wall and I really struggle to finish things. Okay, so all power supply MOSFETs are now fitted, but remember earlier I said that I found some vibration damage, and this is what we have on the rectifiers. This rectifier, I think this, oh no, this isn't a rectifier, sorry, this is not a rectifier, this is a 7812. This is a voltage regulator. So here are our rectifiers here for the power supply and the rail voltage. Here is our 7812 voltage regulator. That has a snapped leg there. There's another one here that's working fine. Now this in itself won't necessarily have caused the amplifier to fail. There's two 7812s. There doesn't need to be two 7812s. One would be perfectly fine, I'm sure, especially on the heatsink like this. But yeah, this 7812 is no longer connected. You can see there, there's no connection there on this middle leg. So this one wasn't doing anything. But this one seems to be okay. It's not dead, it's not shorted, so it was providing the output circuit with its correct voltage and stuff like that. But the fact that we have this here leads me to believe that actually this MOSFET that I snapped off earlier that felt very loose probably did have a snapped leg, and that's what's caused this failure. It probably was just vibration damage here. So I'm going to remove this 7812 regulator, and I'm going to fit, I don't know, I'll fit a new one. I could resolder the leg, or I could fit a new one, because it's absolutely fine, it just needs a new leg. Yeah, look at that. That has no middle leg anymore, so I'll probably just put a new leg on it, to be fair. It's going to be fine. Actually, you know, it looks like this other leg is also pretty badly fatigued. So I'm gonna actually snap all the legs off, including this one. I'm just gonna put 3 new legs on, and then it will be good to go. So let's tin the legs. And I'm actually just going to hold this down with a little bit of tack so it doesn't keep floating around and moving around all over the place. There we go. Now let's get some new legs. Don't need to be super thick. This is a pretty low current device, and we've got another one in parallel with it anyway. So I'm not going to go for super thick legs. A little bit of flux. I missed you too, Zed. I missed you too, my man. How do you find schematics for certain amps? I don't really use schematics. Very rarely I use a schematic. Only if I'm working on a amplifier that has a circuit design that I'm not super familiar with, and it has components that are blown beyond recognition, and I can't guess what they are easily. But yeah, the only time I'd really need to use a schematic is, like I say, if there's like resistors that are burned in an area that I can't easily work out what they are, and it's not a circuit that I recognize, that I'm familiar with. So yeah, I don't really tend to use schematics very often. I just tend to work out what the circuit's doing just by looking at it. What type of solder do you like to use? So I use 6040 leaded solder, which it's not some countries it's not actually legal to use leaded solder now, but there is absolutely no comparison. Leaded solder is just so much better for longevity, for ease of use. Doesn't like crack as easily with vibration and changes in humidity and temperature and stuff. It's also safer to use because the kind of flux that you need for lead-free solder is really nasty fumes. So yeah, 6040 is what I go for. The brand, whatever's cheap really. Like, as long as, you know, well, the metal's the metal, isn't it? It's lead and it's tin, so you can't really go wrong there. The main difference is, I think, personally, between expensive or good solder and bad solder will just be the quality of the rosin core. But the one that I bought recently seems to be fine. Seems to work really well. What brand are you? This brand is Warning. So some Warning solder. No, what actually is it? It is, I don't know, because it has come off. But yeah, that's what I have. Don't know what the brand was since it's come off. Oh, I just sucked the holes from the wrong bloody component. That was the output FET. I need to do this one. Notice how I'm not holding the iron on for too long because I don't want the heat to soak up to the old legs that I just soldered to. So there we go, that's good. Okay, so now we have potentially a fully repaired power supply section. So what we're going to do next is power the board up slowly. Okay, now the output section did have a failure. We had 2 dead MOSFETs over here in this bank. Now it's always hit and miss, it's always 50-50 as to whether the drive circuit has been damaged as well on the output side. So I'm going to power the amplifier up slowly and see where all the rail voltages are and see whether the drive circuit survived. If the drive circuit survived, I'm going to replace all of the output MOSFETs with brand new matching batch MOSFETs. If the drive circuit didn't survive, then we'll repair the drive circuit first. One kind of cool way to just do a quick check of the drive circuit to see if it's definitely failed or not is to check across the bootstrap diode. If that is shorted, if that reads a low resistance, then the driver might be dead, or the bootstrap diode might be dead itself. Or this little capacitor here, which is for the high side bootstrap as well. If that reads a low resistance or it's shorted, then you might have a bad driver as well. But that seems to be doing okay. We have a value one way and nothing the other way, which is good. Bootstrap diode, again, we have 428 one way and we have nothing the other way, which is a good sign. So I'll be willing to bet the drive circuit's probably okay. So provided that these MOSFETs are okay, I found 2 shorted ones, and I believe these ones are going to probably be okay as well. We have 1786 one way, 676 the other way. Let's check that over on the other side. Yeah, that looks like the same kind of value, so I would imagine the drive circuit's fine. So let's power her up and let's start at a nice safe voltage of about 9.5 volts. Keep the rail voltage down nice and safe. And let's see if we get output switching or not. Let's turn that up a little bit. Let's turn that there. So let's pulse the remote a couple of times, get a little bit of rail voltage in the output section. Okay, there we go. So we should have high side over here. So as you can see, a little bit of positive rail building there. Got about 14 volts there on the positive rail. We should have absolutely nothing on the low side drain, which is good. We don't have any voltage on the low side drain. That's a good sign. Let's check the other side. We have low side with nothing on the drain and positive rail over here on the high side. That's pretty good. Excellent. So let's put our oscilloscope probe on the low side and let's power it up to full rail and see what happens. Okay, we have Class D switching, 1.3 amps worth of idle current draw. A little bit of ringing there on the Class D switch wave, but that's pretty common, to be honest. If it's, you know, if the filter network is not the most optimized and stuff like that. So okay, cool, love to see it. Let's just check the other side. Notice how the Class D switching only starts when the relay kicks in. I imagine there's like a 100 ohm resistor or something after the relay that allows that to happen. A little bit of a load on the MOSFET. So yeah, drive circuit all fine. This amplifier is now working. We just need new output FETs. Now, do we have different batches still in the outputs? We do. So the output MOSFETs are actually all different batch here. This one here is a P05 something. This one's a P738. This one here is a P05 again. So we've got all different batches in the output FETs. So I'm going to turn the voltage up a little bit now, and I'm going to get my thermal imaging camera, and I'm just curious to see whether any of them were out of tolerance enough that they would get hot under idle operation like that. 1.7 amps idle current draw. Let's see if any of these FETs heat up. Also a good idea to check our power supply FETs that we just repaired. None of those are getting hot, that's good to see. So the things that are getting hot on the board is you've got this big 5 watt resistor that's probably got rail voltage or switching on it going to ground. We've got these resistors over here which are probably pull down resistors for the rails or something like that. I've got 2 that are the same value, so I'd say that that's the case. The output FETs though do seem to be running pretty stone cold. These 7812s actually do run kind of hot, you know. One of them is running a lot hotter than the other. It's kind of interesting. They should be both running the same, given that they are in parallel, but okay. But yeah, all the FETs are actually running pretty cool here. So it's likely that their VT or their well, we don't know about their RDS. We could check that actually. We could check that. So the fact that none of them were getting super hot means that their VT is going to be, what was that? What disconnected? Something disconnected. Hat cam? No. What camera have I lost? Okay, I think I can see. I think I've lost my multimeter cam. That's fine. But what I was saying, the VT is probably pretty well matched across the different batches of FETs, because none of them were getting hot switching at idle there. However, if we give them a load to drive, we might be able to see differences in RDS, because the ones with the lower RDS will pass more current. So let's hook up a 16 ohm load on the speaker terminals and play some tones, and let's see whether any of those original FETs get hotter than the others. Because if they do, then it means that the RDS value is different between those FETs, and that might have been why it failed in the first place. And given that I'm supposed to be doing a little bit of R&D with these amplifiers for the company that sent these in, this is a great test to do. Because if the RDS values are different and we get uneven heating on the FETs, then I can go back to them and say, well, this amplifier failed most likely due to vibration damage, so strengthen the boards up, but could also fail in future due to uneven loading on the output FETs due to bad matching of the FETs. So just going to place that in. Now the problem is these are Tiffany RCAs, so I actually disconnected them from the board here. This might be annoying to actually set up and do. Let's get that put there. Is that going to reach? Okay, will it reach? Oh, it might just about reach. Come on. Turn these down a little bit. Let's get these down to minimum. Actually, you know what? All of these knobs feel like they were like turned up to the max as well. So that also could be why it failed. It could have just been abused. Line in and line input. The one on the inside is line input. Okay, is that going to reach? Come on. There we go. Let's plug the RCA in. You know what? I'm not going to do it like that. I'm going to do it a different way. I'm probably just going to touch, because fortunately my power supply shares common ground with the RCAs. I can just touch the RCA tip on the pin here that's required for the input, and it will be fine because it shares common ground. So let's have a look. Let's see. I've got. Let's turn the frequency up a little bit, about 50 Hertz, and turn that down. And let's have a look and see whether the output FETs get hot or not. Let's calibrate a bit of signal. 5 milliseconds of high, reject low high frequency. Okay. Let's get that turned on. Okay. There we go. There's a little bit of signal. So I need to turn that up a little bit. Get a little bit of current drawn. There we go. So we're now up at 2 amps. So let's have a look at the output MOSFETs and just see whether any of them heat up unevenly. I'm going to go a little bit higher actually than 2 amps. Turn the gain up a little bit. I think, is this one the gain? Probably, yeah, there we go. There we go, there's 3 amps, there we go. So now we should start getting some heat on the output FETs. They're very slow to heat up. Okay, let's give it a bit more signal. Five amps. Damn, these are staying really cool. This is obviously very cool operation amplifier. Okay, let's go up a little bit higher. Let's just get some more current in this. Right, we'll go right up to, there we go, 10 amps. There we go. Fuck you. 10 amps. How you doing? Now we should start seeing some heat on these FETs. Sheesh! They're really not getting that hot at all. I'm quite surprised, considering it's off the heatsink here. So we've got a little bit of heat on the rectifier diodes actually. Rectifiers are actually getting kind of warm here. And the output FETs themselves, they're freaking chilling! What the hell? Damn! So the weak point then in this amplifier is going to be these rectifiers. Needs a couple more rectifiers, I'd say. They're about 43 degrees. Damn! Fair play. We're right up at clip point now. Alright, turn it off. I'm just going to go across them with my finger to feel. So these are all like almost stone cold. And so are these. The only things that are hot really are the rectifiers getting a little bit toasty. Okay, so this amplifier, although it had different batches of MOSFETs in the output section, it's clear that they are all pretty well RDS and VT matched. So the fact that different batches were used didn't cause this amplifier to fail or really cause any problems. It was vibration damage that killed this amplifier. And the weak point in this amp appears to be the rectifier diodes, because obviously drawing current across the amplifier as a whole, where things get hot will show you bottlenecks, where it will show you where the highest point of resistance is across the whole amplifier. So we've just done a very slow burn, just like a very low amount of current, like 10 amps is nothing. This amp can draw like, I don't know, whatever it is, 150 amps or something, whatever. So 10 amps is nothing, but it has shown that for prolonged current draws, the rectifier diodes are the bottleneck in this amplifier. So that's one thing I can go back and say. So 17812 being disconnected when the amp blew won't have changed anything. This amplifier doesn't need two 7812s paralleled to run the drive circuitry, etc. It might do if the 7812s weren't attached to the heatsink, but even just now we've clearly seen, I was running the amplifier there at 14 volts and the 7812s, both of them there, stabilized at about 40 degrees. Having just one running and driving the circuit would have stabilized out of the heatsink probably 70-80 degrees Celsius, which is a bit high, but because they're clamped to the heatsink, that's absolutely fine. One 7812 is absolutely fine for the circuit. It doesn't need two, but it has them anyway because this circuit has been kind of copied from a bigger version of this circuit where it might have needed two 7812s. Although, to be honest, I don't think any of them ever really needed two. But the kind of circuit that usually uses two 7812s in parallel has four IRS 21844S drive ICs. This amplifier only has two, and you don't need two 7812s for just a pair of 21844S drivers. So one being disconnected won't have caused the amplifier to fail or caused any issues. Okay, rail voltage is now back down at 0, so we are safe to now go ahead and swap out all of the FETs. Anytime you pass current through any device, it's going to heat up. That's how electricity works. But by looking at which components start heating up the most out of the heatsink like this especially, you can see which components across the path of current have the most resistance, are the bottlenecks. Some amplifiers, when I do this test, it's the output FETs that heat up first. Some amplifiers, it's the power supply FETs that heat up the most first. And in this case, it's the rectifier diodes that heat up the most first. So if this amplifier was fitted with more paralleled rectifier diodes, it might actually produce a bit more power. Not loads more, but a bit more. So it's going to drop out these 640s. Now, in my opinion, this amplifier actually has a bit of potential for being upgraded a little bit. It's never going to make much more power at 1 ohm. However, this amplifier is rated for 1500 watts, which is not much power by today's standard. Look at the tiny size of the modern Brazilian amplifiers that produce like 1500 watts. They're tiny. They're almost like the same size as a head unit. So, given that this amplifier is quite big for its power rating, the power supply transformers, it uses 3 very small power supply transformers. I think there's actually some potential to upgrade this amplifier to produce quite a lot more power into 0.5. I think that by replacing just a few components, we could squeeze close to 3000 watts RMS at 0.5 from this amplifier pretty reliably. What we'd need is some replacement output FETs, some better output FETs, which would be drivable by this drive circuit. We've got 2 IRS 21844S drivers, and we only have 12 output FETs. That can easily drive some more powerful Mosfets with higher gate capacitance and gate charge and input capacitance, no problem. Might need some gate resistor changes, but that should be absolutely fine. we can definitely replace the power supply MOSFETs with something a bit more powerful. For example, 7537, 7530s, 1404s, something like that. Then we can increase the switching frequency of the power supply to better make use of the transformers, get a bit more power throughput from the transformers before they saturate at a higher frequency. We could probably kick it up to about 70 kilohertz or something like that on this size of transformer without any issues whatsoever. And most importantly, we would need to add some more rectifier diodes in parallel. Either that or find some rectifier diodes in this package that are a bit more powerful, but I honestly think that we need a few more in parallel. So if we could find some space along the heatsink for some more rectifier diodes, we could bodge some of those in, bodge some more diodes in parallel, upgrade all the FETs, like I said, change the frequency of the transformers, and I think this amplifier would actually be good for about 3K at 0.5. Like, genuinely, I think it would be pretty reliable at that. It has the foundations to support it, I think. Even at 100 amps, 70 watts should be more than fine for a heatsink's TO220 diode. Exactly, yeah. Jordan says he repaired a Smart 5 recently and the output FETs would heat up pretty quick at idle. Never could figure out this issue. So basically the reason that they're going to get hot at idle, the Smart 5 runs those MOSFETs pretty close to their breakdown limit. And if it's the regular Smart 5, I think the Class D switching frequency from the top of my head is a little high. It's not super high, but it's like, it's high enough that you're going to get some cross conduction at idle. Having the output MOSFETs get hot at idle isn't necessarily a bad thing. It just means that there's a bit of cross conduction because of a few factors. Either the MOSFETs are very powerful and they're very slow to turn on and off, and so therefore you get a little bit of cross conduction, or the Class D switching frequency is a bit too high, so you get a bit of cross conduction. Or there's not quite enough dead time, which you can take a bit of extra cross conduction for a bit less dead time to get a bit lower THD. So you can sacrifice some efficiency and you can get some more cross conduction to get a bit of better THD. Not that that's really a problem. You wouldn't really. That's not a concern for a Tarrant Smart 5. You don't really care about the THD so much, you just want the most reliable operation, highest efficiency possible, because it's low frequencies, so it doesn't really matter. But yeah, I imagine that the FETs get hot because there's a bit too much cross conduction due to the slow, sluggish speed of those FETs and the switching frequency that they've chosen to use. The Smart 5, I think. What drivers does the Smart 5 use? Is it the 20957s? Make sure, if you're repairing that, make sure that the dead time is set to the highest preset, the highest setting of dead time. Just make sure it is that. What's your all-time favourite amp and sub? I can't answer that. It depends too much on the application. I honestly have no idea. Okie dokie. Let's drop in some new 640Ns, and we're also going to need a new gate resistor. Very rare to see that actually on the output section. Though to be honest, that would make sense. If this MOSFET snapped one of its legs, then it could actually have been dumping current through the gate path to source without really affecting the rest of the circuit. If it snapped, say for example, the drain leg, then this MOSFET might have shorted internally. But if the drain leg wasn't connected, then it wouldn't really have upset the rest of the circuit, other than the fact that it was drawing a bunch of current through the gate path, which has burnt this resistor and ultimately caused the gate drive to not be strong enough on the rest of the FETs, therefore killing one of the other ones. So yeah, what value is that anyway? That's, what's that, brown, red, brown, gold? Don't think I know that value off the top of my head. What's brown? Brown's 1, isn't it? So that's 1, 2, brown. 120 ohms? Is that right? Yeah, 120. I don't actually think I have a spare 120 resistor. I don't think I've ever used a 120 before for anything. So I might have to order some resistors before I can put this back in the heatsink. But we can definitely kit it out with new FETs first. We'll be doing PA amplifier live streams anytime soon. Possibly soon. I have about 5 PA amplifiers that need repairing. So I do plan on doing those on live stream sometime soon. On the SCAR RP2000.1s, would you say the Chinese type for Class D is very common for 1 to 2 blown output MOSFETs? Yes, Stephen, absolutely. That basic circuit design, for some reason, is super common to just have like a couple of blown output FETs, a couple of blown gate resistors, and that's it. Yeah, I have a feeling that one of the reasons for that happening is a lot of those amplifiers seem to have really poor gate drive. Like if you probe the gate drive wave, it's really curvy with a massive spike on the FET turn-on point. And I think that as a result of that, the MOSFETs are kind of switching softer, and depending on the variance in the VT between the paralleled FETs, you can get a couple of FETs doing more work than others. That's just one guess. That's just my guess. But the same thing happens with the base phase DB1.3s. You get just like a couple of blown output FETs for like seemingly no reason. And the gate resistors blow as well. Frequency of drive, Jordan says, was 122 kilohertz. Yeah, what MOSFETs is that using? The outputs, is it using like 4227s? Because 122 kilohertz is on the higher end of what I would generally recommend for those FETs. Something like 70 kilohertz would be a bit better. But the downside to having a slower switching frequency on the output FETs, although it means that you get less cross conduction and you can run much bigger, beefier FETs without issue, it means that your output inductors need to be much bigger. So there's a kind of sweet spot somewhere. A little bit of cross conduction, small output inductors, less energy lost through the filter network. If one or two output MOSFETs blow, would you just out of good measure replace the gate resistors? Not necessarily. Possibly. The kind of gate resistors that those amplifiers use are little surface mount ones. Generally, if they've been damaged or weakened in any way, their resistance will swing a little bit. It will change slightly. So if you read the resistance of the resistors and they're all like absolutely perfect, dead on within tolerance, then the way that the MOSFET failed probably didn't shove any current down the gate path, so you probably don't need to change the gate resistors. But if one of your 10 ohm gates is reading like 10.9 and all the others are reading like almost dead on 10, then definitely change that one. Or if it's reading like 11 ohms or something, or like a little bit different to the others, then change it. But if it's within tolerance based on the others, then it's probably fine, and the way that the FET failed didn't actually send current down the gate path. But at the end of the day, those resistors are like less than a penny each, so I guess you might as well replace it anyway, but I don't always do that. David, at lower switching speeds, there will also be less resolution. Yes, absolutely. That's why you see full range Class D amplifiers with a much higher switching frequency. But for subwoofer application, you don't need the resolution because the frequencies are so low. So you can get away with much slower switching frequencies on Class D for subwoofer amplifiers, and you can make use of much beefier MOSFETs that are slower, that don't like higher switching frequencies. You can take advantage of those because you don't need the high resolution for these low frequencies. But yeah, it becomes an issue when you're talking about trying to get really high power full range amplifiers in a small package using 4227s or something like that on full range amplifiers, and you're trying to switch the FETs at like 350 kilohertz or something. They're going to run hot out idle, man. There's no way around it. Unless you run some ridiculously high dead time, but then you're just adding a bunch of THD. So yeah, it's a trade-off. What was the switching frequency on the NX6000? Oh, man, you know what? I can't even bloody remember. You know what? I have a feeling it was... I'm trying to think back. I've got a feeling it was something like 350. Because if it was really high, if it was like 600 or 800 kilohertz, I would have remembered, because I would have remembered thinking, whoa, bloody hell, that's sick. But I don't remember being like that. The NX6000 did use 4227s. And it used 2092 drivers, I think. I think it was like up at 300,000. So there would have been some cross conduction there, I think. I can't remember what mode the 2092 drivers were in regards to dead time. Not sure. But if you've got the NU3000, just pop the top off and whack the scope on it, man. Have a look, see what the switching frequency is. And you can also use your multimeter with the amplifier powered off to see what mode the drive IC is in regards to dead time. Because you just check the resistance between the dead time pin and VDD or ground, depending on how they've done it. 120 ohms is mega high for a gate resistor on the output FETs. Oh, you know what? Even though this resistor looks a bit visibly burnt, it's actually still reading within tolerance of the rest of them. Now, obviously, I'm not going to leave it like that. However, that does mean that I can power it up right now on the workbench just to make sure that everything works, okay? And to make sure that, well, I want to actually see what the drive wave looks like. 120 ohm gate resistors in the output section. Usually with 640Ns, you'd use 10 ohms or like 22 at most. 120 is mega high. So I want to see how that impacts the low side drive wave here. So let's power it up. First of all, make sure that it still works with the new FETs in, which it should do. There should be no reason why it wouldn't. And then we're going to have a look at the gate drive waveform and see what it looks like. So let's do a cheeky power up. Make sure there's no solder bridges that I've made anywhere on here first. Yeah, it looks good. Make sure that this still works. Let's turn this scope up a little bit so we can see the switching wave. There we go, 1.3 amps out of current draw. Okay, so we are all good. So now I'm going to probe the drive wave, low side drive. What are we saying here? I'm going to go to the scope screen. We're going to AC couple, go down to about 5 volts divide. There's a lot of noise on here, but let's ignore that for now. You know what? It's not even that bad. I was expecting it to look a lot worse than that. It's not even that bad. 120 ohms. Who would have thunk it? It's pretty curvy. Like, it's not amazing, but it's actually better. It's actually better than some of those Chinese base phase SCAR RP 2000 type of amplifiers. That's before the gate resistor, and that's after the gate resistor. It's not even that bad. One thing which I wanted to look for here was an obvious spike when the Mosfet turns on, which might be like somewhere halfway up here, but there isn't really. There's no dip or spike when the Mosfet turns on. Turns off nice and quick as well, thanks to the parallel diode. But to be honest, one of the reasons that this works so well with 120 ohm gates is because we have the parallel diodes. So one of the biggest issues with having high value gate resistors is the MOSFETs, they don't turn off quick enough before the high side turns on, like before the other side turns on. But we've got 120 ohms on the on phase of the drive signal, but then on the off cycle of the drive signal, the actual the voltage will go through this diode. So essentially we've got 120 ohms on, and then whatever the equivalent resistance or voltage drop would be across the diode on the off cycle. So that's how that's working so nicely. That's very true. Straight up, that's very true. EMC testing, that's one of the reasons why you find some of the Sundown Salt amplifiers and some of the Orion HCCA amplifiers coming with 270 ohm gate resistors in the power supply, massively soft switching the power supply FETs to reduce EMI, but actually bottlenecking and sandbagging the power supply section in the process. So cool, this amplifier is well and truly fixed. We just need a new resistor in the output section for that gate resistor, but that's something we can order, and I will sort that out at a later date. So let's put this amplifier to one side, move on to something else. It's interesting actually how they put the output side loading resistor after the relay, it looks like. Yeah, we've got a 100 ohm resistor here, but it's after the bloody relay. That's a design oversight. That's something else I can go back and tell them. Basically, the reason that there's a 100 ohm relay there, 100 ohm resistor, the resistor is on the output MOSFETs after the filter network to ground. And the reason it's there is it gives some load to the output MOSFETs so that they can start switching. They need a little bit of load across the filter network in order for the filter network to actually work and the class C switching to self-oscillate. Now, that resistor, that 100 ohm resistor, should be before the relay because you want class D switching to initialize before the relay clicks in. But in this case, they've designed it wrong and they've put the resistor that loads the output FETs after the relay. So the output section only actually initializes once the relay clicks in, which is not the intended desired operation mode. You don't want it to work like that. The resistor should be before the relay. So that's one thing I can go back and tell them needs to be changed. Okay, what we got next then? I can do a big one or a small one. Should we have a look at a big one? What we got here? We have the in-phase IP, what is this? IPA 7000. So this is basically going to be a 3000 watt RMS version of that amplifier that we just looked at. So we can see what the differences are. It'll be interesting to see whether the same kind of design flaws have carried over to the bigger one. There's a Texas Instruments all-in-one Class D amp chip for head units, 4 times low power, 50 watts, that switches at 2.1 megahertz. Whoa! That's incredible. That's insane. That's the kind of thing you get from having the Class D amplifier circuit be completely integrated and absolutely perfectly designed and optimized and stuck onto one piece of silicon die. Wow! Mamma mia! That's a spicy switching frequency. Alright, let's put all of the screws for the 1.5K into a little baggie here. Keep them separate so we don't get them mixed up. Is everybody enjoying the stream? Give me a heads up, give me a shout if you're enjoying the stream, guys. It's been a while since I've done a stream and I'm enjoying it. It's good fun. It's taking me much longer to repair these things because I'm streaming, but that's the nature of it. We're all having fun. It's all good. It's nice chatting to you guys and catching up. It's really nice seeing some familiar names and stuff, man, from like streaming for all these years. Straight up says, oh, Blake B says, I got the joy of spending the last 3 hours sanding inside a box until it sounded less shit. That's jokes, man. The things we do for bass, eh? Straight up, I've developed switching power supplies that switched at 1 megahertz. The inductor was super tiny. Yeah, I can imagine. That's awesome. Fucking good job, man. That's sick, straight up. I was thinking I ordered the wrong part when the PCB showed up. Jesus. Wazza, sending amps to you tomorrow. Awesome. I have a pretty big wait at the moment. Just a heads up, might be about 3 to 5 weeks or something like that. So sorry about that if it's a bit long. Okay. What have we got in here then, my friends? This one didn't have a sticker on the box to tell me what happened to it. Okay, we have a split PCB. PCB split into 2 halves, but we have solid copper jumpers. So, okay, interesting. That doesn't really make it any easier to work on. That's fine. We have the exact same drive circuit that we had in the IPA 3000. This is the IPA 7000. We've got twin 21844S drivers. We have, yep, output FETs are probably going to be either 38N30s or 24N40s. Loads more rectifier diodes. Look at this, we've got 8 rectifier diodes now instead of just 2. The power supply FET's probably going to be 064Ns. Now it doesn't look like we have a power supply section failure because nothing's burnt. So let's go ahead and have a look with our multimeter. I'm going to have to reset the multimeter camera because that screwed up and that's now frozen. Give me a sec. Reset that. That should come back to life. There we go. Blake says, do you prefer the screws or the clips? Generally I prefer the screws because I can be confident that there is solid clamping pressure. The problem with the clips is if the clips get damaged or whatever, then they don't necessarily actually push very hard on the FET against the heatsink. I've encountered that before. However, saying that, the clips are actually faster to remove and install because you just clip it off, bang it on. Secondly, the issue, one of the issues with the screws is that the aluminium heat sinks are made of like cheese. So occasionally the threads will just disappear. Like you're screwing it in and it just won't get tight. And that's one of the reasons why I use a manual screwdriver, because it's really important to feel the torque and feel the back, feel the force on the screw. Because if it starts feeling like, oh, that felt like it was getting a bit looser, you want to stop. Like using an electric fucking screwdriver, you have no idea what's going to happen with that. So manual screwdriver. But yeah, it can be a massive ball ache when one of those threads just disappears and screws up. Because then you got to find either a longer screw, thicker screw, rethread it. It can just be a massive pain in the ass. Also, the screws are made of cheese as well. Sometimes these screws just snap. And then you've got the thread in the hole and you've got to try and use pliers to get it out. Yeah, I've had much more headaches with the screw type clamps than I have with the clip type clamps. So is that an LTT screwdriver? Yes, love it. I didn't buy it. A viewer very kindly bought this for me and sent it in. Had no idea. So freaking awesome. Yeah, I love it. Really cool. Would I pay £80 for it? Probably not, but it is awesome nonetheless. Right, output FETs. No shorts over here. No shorts over here. Ah, what's this? We have one dead Mosfet there. Okay, let's pop that out. We're using 24N40s. So 24N40s, pretty good to use in a 3K RMS amplifier. There's plenty of voltage headroom. These are 400 volt FETs in a 3K amplifier with 3K rail voltage. They're going to have plenty of headroom. The safe operational range of these FETs, they'll be able to pretty much give loads of current at the lower rail voltage. So yeah, I'm a pretty big fan of using the 24N40s here in the 3K amplifier. Not too bad. This one, however, is dead. So let's cut that out and see what else is wrong. So now that we've cut that out, it looks like the short has disappeared. So we got, oh no, we got another dead FET as well. Looks like we lost one low side and one high side FET. This is very similar to the kind of failures you see in the Chinese half bridge amps using the optocouplers, like the Scar RP2K and Audio Bank and stuff like that. Digital Design's DM series. Okay, wait. Let me try this. Semir. Let me try this. DDZ2. Amif. No. Fuck. No. Start again. Hang on. DDZ2. Amphi. Var. Elimde Gondesem Tamir Edomizin DDZ2 Amphivar Elmide Gondesem Tamir Edomizin. Can anyone translate that for me? Okay, so dead output FETs gone. This yellow thermal pad, it's almost impossible to remove the FET without absolutely ripping the butt out of the thermal pad. So often this needs replacing. Yes, ripped. You can see there on the back of the FET, we got half of the thermal pad on there. Bollocks. Probably would have been better if I twisted it off like that, actually. So we still have, okay, cool. We still have most of those output FETs. We've got two high side, two low side left. So let's see if the short circuit has gone away. Yep, and there's no power supply failure because we have voltage still sitting in the caps for the power supply. The drive circuit, we can probe the bootstrap diode and have a look, see whether we've got dead bootstrap diode or not. No, that looks pretty good. Bootstrap capacitor looks pretty good, so the drive circuit's probably right. So I reckon if I power this amplifier up, it's going to come alive. Two output FETs died. Not sure why. We sometimes will never know, but I'm just going to see if I can find a reason for that. So let's get some power wires in here, see what happens. I have an amp. Oh, the translation says, I have an amp. Can you fix it if I send it? So, if you want me to fix an amp, unfortunately you have to live in the UK. I don't take work from overseas for a bunch of reasons. Shipping, import duty tax is freaking expensive as hell. If I've got to ship it back to you and it's expensive, if there's an issue that I would cover under warranty, I can't really help you because the shipping is really expensive, so like, oh, I'm not going to cover that under the warranty. Like, I'll do the repair under warranty, but I'm not going to pay for the shipping back from overseas under warranty. So it's very tricky. Yeah, I don't take work from overseas for a bunch of reasons. That's a couple of reasons, unfortunately. But if you're in the UK, then yeah. But if you're not, then no. Sorry. Wait, a DDZ2. That's going to be expensive to repair if it's a full rebuild as well. Yuri M says, hi from South Africa, bro. How's it going? Is there any car audio build in the Proton? Yeah, man. I did a video. Go and watch the video. It's called Come for a Drive with Me on my channel. You can see a little bit of the sound system in the Proton, maybe. It has the T-line door cards, has the Genesis 8-channel Class A Class AB dual mono amplifier, has the A series digital design speakers in the A pillars, has the 9855R, has the bass face Indie S prototype in a L-ported box on an Alpine MR PM 500. It's an SQ build. It sounds freaking awesome. Okay. So let's power this up. 9.5 volts, nice and low to start with. Build a little bit of rail voltage. A little bit of rail voltage. Okay, so we got high side over here. Let's turn this back onto DC coupling so we can actually see that on the scope. Yep, okay, let's check to see whether we have any DC on the low side, which we don't, which is great. Means the drive circuit's probably okay. So let's go for a full power up and see what happens. Yeah. It's got the same design flaw as the IPA 3K. Where's the resistor? Fucking hell. I bet it's this one in the middle. Wait. Where's the output side load resistor? The 100 ohm. Is it this? I bet it's this. I bet it's this. Right. Watch this, okay? Probe the low side drain, okay? Amplifier powers up. See now? Powered up. It's trying to power up, but it can't because there's no load. Relay clicks in. As soon as the relay clicks in, we get Class D switching. That is because they put their freaking output side load resistor after the relays. What are you doing? That's a stupid design flaw, that is. Put it before the relays, so that the Class D initializes before you get a connection to the speaker terminals. Yuri, you said you're doing games, consoles, and phones. That's some tiny stuff, man. That's some small stuff. I've given a go at repairing laptop before, my own laptop, but it had a dead GPU, like the actual GPU chip itself, so that wasn't a no-go. Yo, CJ, how's it going, my man? Good to see you on the stream. BH4 says, hey Bevids. Wait. Hey Bevids. Zou je in verstukken uit Europa repareren als ik deze na ju verstuur. All in one go. Zou je in verstukken uit Europa repareren als ik deze naar ju verstuur? How's that? sounds legit. Same, like, fucking fluent. Absolutely fluent. I could stand up in court and say that with no problems. Right, well, this amplifier clearly is boring because it works fine apart from having 2 dead output FETs. So there is, if you are doing amplifier repair or you're wanting to do amplifier repair for customers, this would be a good opportunity to... Hang on a minute. What's this? This screw, the screw for this fan is loose. Oh, shit. That wasn't even screwed in at all. It could be vibration that's done that. I wonder actually whether this has a bit of vibration damage to the output inductor. I'm going to power it up on 9.4 volts, nice and low. And I'm just going to wiggle the output inductor and see if anything blows up. Class C switching, yep, there we go. No, the inductor's fine. That one's a little bit wobbly, but that's okay as well. Yeah, it seems alright. So I think this amplifier has been subjected to a little bit of vibration, possibly over its... Oh! Yeah. Vibrazione. Vibrazione probleme. So that is a rectifier diode. Now, that having vibration damage and snapping the legs, that won't inherently have caused the amplifier to fail unless so when you've got a like an intermittent connection like that, if you've got a leg that is just like touching on the other leg and under vibrations it's like arcing and just making breaking, it can actually cause some pretty hectic like spikes and stuff on the rail voltage, which could upset parts of the circuit, the output circuit, the Mosfets. It could even actually cause the rail voltage to rise higher than intended. But given that these FETs are 24N40s, they're 400 volt FETs, it'd have to boost the rail voltage like mega high before any issues happen. So that's not a problem here. So I don't think that caused the amplifier to fail, but it's not a good sign. It means that this amplifier has been subjected to some vibrations, but also like this amplifier circuit, okay, this amplifier circuit isn't bad. It's not a bad circuit. It has a couple of like slight design oversights, but it's not a bad circuit design. The biggest issue with this amplifier is just its build quality. Like, it has absolutely no central support screws, so this board is going to have like a pretty low resonant frequency, and it's going to actually flex and quite badly with vibration, especially if it's mounted to an enclosure. All this needs is some screws down the middle to really make a massive difference and prevent this kind of thing happening. So yeah, when it comes to repairing this one, I will strip it out the board and I'll check everything. I'll check all the rest of the legs for signs of fatigue from vibration. But yeah, I think that's going to be the common factor across all of these in-phase amplifiers, is just going to be that the circuit's fine, acceptable, like very similar to lots of other way more respected brands. Just a couple of things that they've done to cut costs in the assembly that have caused them to be less reliable than the others. Just in the assembly of it. The Mad Scientist Audio says, I see broken legs. That was pretty keen eye, I have to say. If you saw those on the stream at the zoom level that I had, that's a pretty keen eye. Lots of micro soldering, yeah, that sounds like fun. I actually really enjoy that kind of thing. That kind of tiny, like BGA, like tiny fucking microscope stuff with tiny chips and resistors and stuff. I actually really enjoy that. It's really, really fun. So that's pretty cool. Do you have any videos, Yuri M? I'll check your channel out if you've got any videos. The Mad Scientist says the resistor is at the speaker terminal. Oh yes, I do see a big chunky resistor at the speaker terminal, so it could be up there. Just been doing more stuff to the Polo, and Vans might have some of my DJ amps to send your way for a refresh. Yeah, no worries. Yeah, I can do that. No worries. Tol Gahan says, I learned a lot from repair videos. Cool, man. Thank you. That's the idea. That's why I throw them out there. I want to get more people on board with fixing shit, man. It's good. It's good thing to do. Okay, so what I'm probably going to do is just put this amplifier down to one side because it's a really easy fix. Just change the output FETs. It already works with the 2 dead FETs cut out, so... Unintentional bus pumping, exactly, yeah. I've actually seen that happen so many times when output FETs fail in a certain way that causes like a flyback effect on the output inductor. It raises the rail voltage through the freaking roof and the rail caps all vent and stuff. It's crazy. Right, I'm just going to whack this amplifier down to one side then. We know what's wrong with this one. Relatively easy fix, nice and easy. We don't have to do this on a video. Just new output FETs, boring. See if we've got another one that's more interesting. Let's put this bag of bits with the other one that we need to get the new resistor for. Let's get a bag for this one. Shall we have a look inside the 24N40? I'm curious to see how big the die is inside actually. Have a quick look. See if we can crack this bad boy open. Just need to grab... Sure. I'm kind of curious to see whether there's any visible damage to the die. Might need a different pliers here. Usually these are quite easy to open. Come on. This one's really hard to open. Jesus, what the hell? And there we go. Yeah, pretty big die actually on this. Like, not bad. You can see, yeah, some signs of failure there. Oh, it's fine. It's just a bit of epoxy over the amp, little cracks of epoxy. That will come out when you flip it upside down. That's no drama. There we go. Hey! Like 2 bits of epoxy fell out, that's fine. Okay, let's have a look at this one. This is a IPA 8701 set fire. Love to see it. This is this a mono class D high current mono amplifier? Yeah. So this is going to be like a smaller version of the 3K. This is probably going to be, I don't know, what, like 800 watts RMS, something like that. So many channels on YouTube doing micro soldering, is there? Haven't looked personally, so I'm not sure, but oh, this one's been taken apart before. It's missing the side piece. So this is missing the side plate somehow. Wait, how is it missing the side plate? Okay, it's been unscrewed, no worries. Oh yeah, this one's been taken apart before. Oh man, sheesh! Oh my days, this one's bad. Whoa! Oh shit, this one really did set on fire. Like, actually did. Like, prolonged fire. On the rectifiers? What the fuck? Is that on the rectifiers? Yeah, it is. What? Hang on a minute. Hang on a minute. Wait, where is it even gone? It's gone. It's gone. It's gone. It's ascended. That someone's removed that already. But hang on a minute, guys. Hang on a freaking minute. This is the smaller version. This is the 8701. This has 1, 2, 3, 4 rectifier diodes. MBRF 2020 CT and CTR. Right? This right here, this is the 1500 watt version. This only has 2. This is the same fucking diode. What? Why does the smaller version have 4 rectifier diodes and the one that does twice the power have 2? What was I telling you about this one with the rectifier diodes being the bottleneck? I guarantee you that's a problem. Wait. Gilulius 771. Bel profumo di Mosfet. Okay. My man here. Oh yeah, how do you even pronounce that word? Teruasta. Teruasta Hyman Suomia. Teruasta Hyman Suomia. Languages are my speciality. Just call me Jaume. Yeah, so basically this is a Victorian Industrial Revolution. This is an amplifier from the Industrial Revolution from like Victorian times. This amplifier would have been mounted to the boiler of a steam locomotive for like some banging tunes in the cab. And this would run on coal, like use some coal in it from like the steam train coal thing, like busting up some coal tunes, some 1920s steam swing tunes. You'll love to see it. And to get this amp out of the case, we're gonna just need to take off this panel because the other one's already been kindly removed for us. Oh yeah, look, wait, it already comes out, hang on. I don't think I can get this out without removing this side piece here. Oh yes, the grand old coal-fired amplifier. Yeah, these have such a lovely warm sound. Just beautiful, like fuzzy, warm sounding amplifier. Just, yeah man, fucking... Right. Ebug says, Sam, what would be your alternative to a 40H65 DFB? I'd probably go with a 70B, a 70B 45 FSG. Probably would be my call for replacement for that. Oh fucking hell. Oh fucking hell, man. Stefan, what are you doing to me, man? Oh, how do you even... what even does that say? KYK. How do you say that? Geek. Geek. Does a K have a different phonetic sound in this language? Like, it's not a K. Maybe it's a... Maybe it's a S. Maybe it's like a C. Like psych. Alright, fuck it. Ek kijk elke dag jouw video's en ek geniet elke oomblik. Haha, bandit. I love that one. That's a sick word, man. Fuck, England should have that word. Oomblik. Yeah, man. How was your night? What was like? You went out, isn't it? Yeah, you went out with your mates. How was your night, bruv? Man, I got fucking oomblicked. It was, oh man, them drinks were flowing. All right, So we're going to obviously have to cut away some PCB here. Yo, this is using some whack ass power supply FETs. What we got in here? What is this? UTC 70N06. I've not seen that make of Mosfet before. That's a new one for me. What? We've got... Why? We've got 4227s in the output section. What? Jesus. Oh wait, hang on a minute. We got 4 times 4227s in the output section. What's this amplifier even rated for? 8701. This amplifier would be capable, given the right like backup of where 4227s fucking, yeah, this amplifier has the potential based on the output FETs to produce like 2.5K, 3K, because the Taram's HT3000 uses 4 4227s or 4 4115s. Can't remember off the top of my head, but I'm pretty sure this thing's only asking like 800 watts. Why are you using 4227s, bruv? Don't need to do that. Could use something else that's cheaper. Do you upgrade or repair? Generally, there's not really a lot of benefit in upgrading most components most of the time. So the thing that dictates an amplifier's output power is basically going to be its rail voltage. You're never going to get like drastically more power from an amplifier without changing the rail voltage. So when you're replacing output MOSFETs, power supply MOSFETs, etc., yeah, you can use better MOSFETs, but you might have to make changes to the drive circuit to accommodate for them, but it's not going to make the amplifier make any more power at its minimum rated impedance that it's designed for. It might run a little bit cooler, might run a little bit more efficiently, possibly, provided you've got no cross conduction, but there's not really a huge benefit in upgrading the MOSFETs just by themselves. Sometimes, if the amplifier has headroom in the transformers, upgrading the MOSFETs all round might allow you to run the amplifier at 0.5, but that depends on how close the transformers are to current saturation at 1 ohm and whether they'll be okay at 0.5, and also with the rectifiers as well. Oh, it's Afrikaans! Damn! I had no idea. Most expensive repair? I think the most expensive repair that I ever did was like £500. I think it was on like a, I don't know, something similar to a Z2C, or like some absolute chungus of a freaking Korean half bridge, like 12-15K, that needed a full rebuild. Like I think it was like 400, 450, £500, something like that. But the amplifier was like worth 3,000 new, so you know. Shit. Oh no, here we go. Man, I don't even know where to freaking start. Ooh. Oh wait. Is that an L? OEL. OEL BM. OEL BM Jack. Naprawiazu te. Oh, fuck. Was it? was Magniaze. Yeah, oh, fuck. Man, there's so many consonants. Give me some vowels, bruv. Why is it? There's too many fucking consonants, man. Bro just gave me a bunch of consonants and expect me to pronounce that shit. Like, pfft. This is clearly not a word. Oh no, this is that town in Wales or something like that, or Ireland, or no, yeah, this is that town in Wales, isn't it? something go go gosh goch or whatever it is. Yeah, I ain't saying that, but I do know of that one. Today's stream is lit as ever. I usually listen, but I've been enjoying the shit out of this one. Thanks, man. I appreciate it. I'm having a bit of fun. The MRP M2000 uses 4 times 4227s. I think that uses the RFP 4227, doesn't it? I'll tell you what, the MRP M2000 I've always referenced as like a really early Brazilian style board. It uses the 2010 drivers with like 4 of those really beefy ass output FETs, and there's a bunch of free space in the heatsink. If you take the back off the M2000, there's like a bunch of free space. Like, I don't know whether that's done just to make it look like a bigger amplifier, because Alpine are obviously on some next brainwave ting, and they're like, yeah, we can make an amplifier with like much less components, but then if we make it too small, people are going to think, oh, hey, this amplifier ain't beefy because it's small. People do perceive that. They place an assumption on an amplifier's performance and how it sounds based on how big it is, how heavy it is, how the potentiometers feel. That is such a human thing that we do. We place an assumption of how something is going to perform or sound based on its physical appearance and its tactile feel. So Alpine probably may have either made it bigger for that reason, or they've done a clever thing where they've made the heatsink bigger for more thermal mass to dissipate the heat from these components, in which case that's fair game. I have a full rebuild Z2C in. That's never a fun time, man. There's a bunch of expensive ass parts in those amplifiers, man. What's a good amp for a Z3 sub? The Steel Killer's literally as much power as you can afford. Like, whatever. Like, freaking whatever, man. Taramps base 15k, Paris PW 15k, MD 12k, Z2C, big ass, just put a big ass amp on that woofer. It's not gonna clamp that much power because the Z3 has monstrous amounts of impedance rise, but you need the high rated power to end up with enough power clamped because of the impedance rise. An alternative solution is to use like a 5 or 8,000 watt RMS amplifier, but wire it down like 0.5 or even 0.25, man. Like, these Z3s have massive amounts of impedance rise. You can wire them down, and it's fine. Just keep your low pass filter low. If you're going to wire down 0.5, 0.25, low pass filter, low. 50 Hertz, 24 dB roll off, because you know what? Even on a Z3, the impedance rise is still really high, even at the higher frequencies. Yeah, fuck it, man. Just wire it down. Yeah, the high impedance rise is due to the ridiculous amounts of motor force. Obviously, impedance rise is as a result of back EMF. It's the impedance rise is caused by voltage potential created by the coil moving in the magnetic field. And the stronger the magnetic field, the more voltage, the more potential is going to be created or generated in the coil moving in the magnetic field. So the stronger the motor and the stronger the motor coil relationship, the more impedance rise will be created. So yeah, the stronger the motor, the more impedance rise you're going to get. But it does require a tight coil gap as well. Having a massive motor, but having a big ass flappy coil gap isn't going to yield as much impedance rise as you think, because there's not as much of that flux density that's actually available to the coil or as it's moving through it. So also depends on the density of the pole piece. So you'll notice that Z3s, Z4s don't have a pole vent, and that's to make words. That's to give the most amount of metal in the pole. The more metal there is in the pole, the more dense the pole is, the more flux it can absorb, and therefore transfer to the coil. Basically, the way that a subwoofer motor works, the actual magnet rings themselves aren't really... The coil doesn't interact with the magnetic flux that the rings themselves have. It's the magnet rings in a regular speaker motor magnet. What they're doing is they are saturating the pole piece with magnetic flux. They're basically turning the pole piece into a magnet, in a sense. Yeah, obviously there will be also some magnetic flux on the outside, but essentially they're they're saturating the pole piece with magnetic flux, with energy that the coil can then react to. So the Z3s and Z4s don't have a pole vent to maximize the amount of magnetic energy flux that can be saturated into the pole. If you've got a massive pole vent, you're actually reducing the amount of fixed stationary magnetic energy that the coil can react to. What size of amplifier would you recommend? Guys, my answer to any of those questions is always going to be the most rated power that you can afford. You can ask me, oh Sam, what amplifier do you recommend to put on a Sony X-Plod? What amplifier do you recommend to put on an NSV4, NSV5, to put on a DC level 4, whatever. The most rated power that you can afford. That's literally it. Okay, the reason that I say that is because the most important factor for subwoofer amplification is dynamic headroom. The further you can stay away from the amplifier's clip limit, the better. The more efficient the amplifier will perform, the more dynamic the sound will be, the cooler the voice coil will run, just everything will be better the further away from the amplifier's clip limit you can stay. So if you are running stock electrical and you have a 300 watt RMS subwoofer, you don't need a 12,000 watt amplifier. But if you have a 12,000 watt amplifier laying around, hook it up and dial the system in, calibrate the amplifier's gain, not to clip point, obviously, because the electrical system in your vehicle can't support it because it's stock. Your subwoofer can't handle it, obviously. Calibrate your amplifier's output to the limit that you run into first, whether that is the electrical system's limit. So obviously if you start dropping below 12 volts, that's your limit. So then you know where to set your amplifier gains to, so that it doesn't draw too much power from your stock electrical system. Or you calibrate it to your subwoofer's limit, whether that be mechanical limit or thermal limit, depending on the enclosure that you have the woofer in. You might be having a massive enclosure, therefore you'll run into mechanical limit first. So you turn the amplifier up until the woofer starts looking like or sounding like it's moving to its limits, back off a little bit. Or the woofer starts getting a bit too warm to the touch after a few minutes of playing, back off a little bit. Having a 12K amplifier there doesn't mean that you're going to kill anything, doesn't mean the amplifier is going to blow because you haven't got the right supply for it. It just means that you have headroom and the amplifier is chilling, is cool. So always my advice will be buy the biggest amplifier you can afford for whatever setup that you're using for your subwoofer application. Obviously, if you're running a 300 watt RMS subwoofer, you don't need a 12K amplifier. But what I mean is, don't buy a 300 watt RMS amplifier, because after impedance rise, you're probably going to run into amplifier clip limit first. Buy a 1500 watt, 2000 watt amplifier. They're cheap enough now. That way, you know you're never going to run into amplifier's clip limit, and your limit will be something else, whether it's vehicle supply, woofer excursion mechanical limit, or woofer thermal limit. That will be your limit. Don't make your limit be amplifier clip limit. Just make it be something else, and then you're going to have a good time. Fucking hell, I've sat here looking at this amplifier for like half an hour now. Let's do something on it. Right. So obviously, the the rectifier diode is toasted, is freaking caught fire. I'm curious to see whether the power supply section survived. Oh, it did. Oh, the power supply section survived, guys. Woo! Wait, these FETs are some beastie FETs. 70N06L. You know what, guys? These MOSFETs that are used here in the power supply section, I think these FETs are just whatever the factory had laying around, or whatever they could get cheap. Because I think these are actually logic, kind of optimized, logic level logic. I don't know, the L makes me think, logic like, it might not be, but often, like for example, IRFL MOSFETs will be designed for logic level operation. I don't know whether that's the case here. This L could mean something else. Could be the package type, could be a bunch of whatever other things. But yeah, these are random, but they survived. So they were able to dump loads of current into whatever situation was happening over here at the rectifiers. And they haven't failed. Let's have a look at the output FETs. Let's see whether they have failed. Oh, come on. Multimeter cam, what are you saying? Come back to life. Come back to me, baby. Oh, waste, man. Right, this is the worst design thing I've ever seen in my life. Guys, I'm just going to show you this for a second. This pisses me right off. See this, right? This is the USB connector for the camera that I have pointed at my multimeter. It's a dual purpose USB. So you can either have USB A, or you can do this and plug it in by micro USB. However, the piece of shit design is that the USB A contacts just rest on these pads here when used in USB A format, and it's a really crappy connection. It just sits on it, and this is kind of wobbly, you know, like, so this is a really unreliable USB connection. I just need to snip it off and just solder a USB A connector to it, but I haven't done that yet. Okay, here we go, back in business. Right, output FETs. Have we lost any output FETs? So these two are looking good. These two over here. Yeah, holy shit. So something happened in this amplifier then that caused the rectifier to catch fire, and I don't know what it was. Could have been something laying, some piece of wire strand that got in the amplifier and caused that to happen, but I guess we'll never really know. Alright, well, let's clean this up and see if we can get this back up and running again. There was obviously a big fire here. Lots of this PCB might need to be taken out. This capacitor will have got mega hot, so probably going to need to replace this. This capacitor, the heat shrink, has definitely shrunk a little bit, but I think this one will probably be fine. The lead of this transformer will be fine as well. Right, let's get a bit of isopropyl alcohol and clean this up a little bit. Wow, look at the state of that. Have you worked on Banda Brazilian amplifiers? Yeah, man. You know what? Banda was the amplifier that I learnt on. I learned to repair car audio amplifiers on Banda amplifiers. So I know them better than anything else, pretty much. Well, maybe not now, but definitely for a long time I knew the Banda amplifiers really well because I learned to repair on them. That was the first amplifiers that I learned to repair on. Yuri, thanks for joining, buddy. I appreciate it, man. Thank you so much, man. Really appreciate you jumping on the stream. Right, let's see how much of this board we need to cut away then. Man, big fire in here. There goes my camera again. Fucking hell, man. See you later, PCB. Yeah, man, I've repaired way worse than this. Go check out my videos. I've repaired way worse than this. This is nothing. This is easy. This is going to be repaired easy. I think I'm gonna remove this rail capacitor just because there's a bunch of burnt carbonized PCB like pretty close to it. Would you recommend a big ass amp at 4 ohms versus a cheap one at 1 ohm for efficiency? No, I wouldn't really. There are, yeah, obviously amplifiers are more efficient at 4 ohms. Like, if efficiency is really important to you, like I think between the 4 ohms and 1 ohm you might get like 8 to 10% differences in efficiency, which to be honest isn't really a huge issue. The problem is at 4 ohms you're going to need to buy such an expensive big amplifier and then use like a quarter of its power. It seems pointless. Just buy a modern efficient 1 ohm amplifier and just use it to its full potential. Because running it at 4 ohms, you're gonna more likely hit the clip point of the amplifier, which is not good for it, and it's just kind of pointless. Right, let's get this rail capacitor out because I just want to clean up the board underneath it. I think this has got a bunch of epoxy. Yeah, it's got a bunch of epoxy on it. Yeah. Oh man, it's really stuck. Usually I can just kind of like push these away. Oh, this one's really stuck. I might what I might do is I might just do 5 minutes more chatting with you guys. I might leave this one for a stream another day, maybe tomorrow, maybe Wednesday, something like that. And we can really get into it and get it fixed. It's getting kind of late here in the UK now, so. Is InPhase related to Vibe? Because the logo seems similar. Nah, they're not related. I mean, they're both UK companies, but nah, they're not related in any way. Alright guys, yeah, a couple more Q&As, couple more chats in, and then yeah, a couple minutes or I'll call it. Call it. Have a little cheeky chocolate bar. Do you ever experience a car with an alternator which randomly turns off? It's scary as hell, bumping like crazy, and you see the voltage dropping. Never experienced that myself. An alternator turning off. The only reason I can think that would happen is if it's overheating and it has like a thermal cutoff, maybe. I've never seen that happen in person. No. How are you doing? Yeah, I'm doing okay. I'm doing alright. I'm not doing too bad. There's always some things in it, but I'm not too bad. Got thermal paste on my freaking arm! I had an alternator die. I had the voltage needle bouncing. Then it dropped to 12.8 and stayed there. Damn. Yeah, I've never cooked an alternator. Never seen one. Quadfeed says, just joined, you look a bit defeated. Nah, man, I'm good. Not defeated at all. This is a fun amplifier to work on. But I've been streaming now for 4 hours. 4 hours on the stream. So just kind of winding things down, chatting to you guys a little bit, answering some questions. Then we'll call it. Yeah, this will be an easy amplifier repair. No dead output FETs, no dead power supply FETs. Rectifier diode obviously had some kind of crazy failure, caught fire, but all we got to do is just cut out the bad PCB, the carbonized PCB, and then just rebuild the traces to a new rectifier diode, and it will work. I think the fire will have affected this film capacitor here. I don't think this will be very happy. I think this rail capacitor will probably be okay, but we can check it with the ESR meter. But apart from that, I don't think anything else will have been affected by it. So yeah, we'll just need to replace this film cap here, which will be the same value as this one over on this side of the board, which is a 400 volt 125J. So that we can replace that, no problem. New rectifier over this side. I'll probably change this rectifier that's next to it as well, just because that would have got really hot. So a couple of new rectifiers, new film cap, maybe a new rail cap, and yeah, it's going to be good to go. And do you think running a car off a switching power supply is a bad idea? No, not a bad idea at all. Apart from the fact that switching power supplies generally don't make enough power for a big car amp. So you said that your amp is clipping bad, random, for 400. But you said the voltage doesn't drop below 14 volts. So give me some info on your setup. Like, firstly, what amplifier you're using, what switching power supply you're using, what subwoofer you're using, and I'll maybe give you some tips. Henrik says, I'm planning on running a pair of DLS components, two-way, in the front. What amp do you recommend for that? So, if you're planning just on in-cabin listening, near-field listening, you don't need a lot of power. Like, literally, you don't need much power. Like, 50 watts, absolutely more than enough. So, depending on whether you are wanting to buy something brand new and have warranty, or whether you're okay having something used, I would, if it was me, probably buy something used. Something from the late 90s, 2000s. I would buy something, obviously, Class AB, like without a doubt. And something that is well respected, known for having a really nice sweet sound, something that has adjustable bias on each channel. Like, I'd probably run a Genesis amplifier or something. Maybe I might even run an old school Alpine V12, maybe an old Rockford, maybe, you know what, even something like a JBL, like maybe not the 75.2, but maybe a JBL GTO, something like that. They're actually pretty nice amps. They actually sound pretty nice. Maybe like DLS. I wouldn't run like a Moscone or like a Zapco or any of this nonsense. Do older amps sound better? Not necessarily, no. But older amps don't necessarily sound better. However, to buy a new amplifier that sounds as good as an older amplifier that you can buy for used market prices, it's going to be massively different. Like, to buy a brand new amplifier that sounds as good as, like, let's say you can pick up an amplifier that sounds amazing on the used market for 80 to 100 pounds. I don't know what, like 100 to 150 bucks, right? To buy something brand new that sounds as good as that, it's probably going to cost you like 400 to 500, maybe. So it's a bit of a no-brainer. You, like, provided it's not been abused and it looks okay, a well-designed amplifier will run for freaking years. You only need to worry about the capacitors and stuff once it gets to like 15, 20 years old, like 20, 25 years old. And you might even have the skills to recap it at very low cost. So I would always recommend buying used. I buy everything used. I can't, you know what, I can't even remember the last time I bought something new. I'll tell you what, I can tell you a tiny handful of things that I bought brand new, for valid reasons. I bought my projector brand new. Reason I bought my projector brand new was because the cost of it brand new wasn't massively miles out different from a used one, and because the bulb lifespan is a thing. It has a degrading component. The bulb, like, you know, and replacing the bulb in a projector is not mega cheap. So buying a used projector with a bulb that's on its way out and having to replace the bulb might be similar cost to a brand new projector. So I bought a brand new projector. The next thing I bought brand new was my air fryer, because it's a cooking implement and I don't want someone else's jank ass, greasy, freaking whatever the hell they've cooked in there before. Like, I'll buy a new air fryer because it's a cooking implement. But anything like amplifier, car, speaker, subwoofer, computer component, graphics card, CPU, power supply, freaking like stuff like that, you buy it used, man, because the extra cost to have it brand new isn't worth the... There's not a great benefit to it being new, other than the fact you maybe get a warranty. And for me, as a technician, if something fails, I will fix it. So I'm not really too fussed. Like, if it fails, there's a small chance it will fail within the first, like, however long of me owning it used. And generally, the thing that you find is that if something is going to break, if something is going to fail, it will fail within the first, like, few months because it had a slightly weak component from factory. So if you buy something used that's already a few years old, chances are it's going to work for, like, many fucking years, like, from now, because it's already past the amount of time that it would have failed from a weak component from factory. So it's a good one. So it will probably continue to work for its, like, serviceable life. So yeah, absolutely. The only thing that I got burnt with, sort of, is I bought a laptop. I bought a Lenovo Legion laptop, i5 GTX 1660, and I had it for about a year, and the GPU failed. I mean, we did used to game on it a little bit, like on trips away. We used to game on it, we used to render videos on it, so the graphics card did get used quite a lot. And because it's a laptop, the graphics card was always thermal throttling. Like, the GPU was always like fucking 90 degrees. So that's probably a case of, like, user abuse. I probably abused it a bit. You know, it's a laptop and I was using it hard. So obviously I bought it used, no warranty, whatever. But because I have the technician mentality, I tried to fix it. I found out that the dead part was the GPU. So I have stripped the laptop and I've sold all of its individual components for the same price that I bought the laptop for. I bought it for £400. And I've sold, like, I've sold the keyboard assembly, the screen assembly, the chassis, the Wi-Fi card, the RAM, all of the individual components of it I've sold, and I have got my money back on the individual components. And I even sold the motherboard as a faulty motherboard, and got some money back for that contributed to the value. So yeah, I will always buy used. Okay, it's 10:30, guys. It's time. Oh, thanks for the 5, Matthew, man. I appreciate that. People bang on to buy it, never buy used GPUs because they could have been used for mining. Exactly, it means nothing. Mining generally under volts, and they want reliability and longevity, so mining's not an issue. Yeah, cards last forever. Well, they last for a long time. I would say graphics cards generally will, provided the graphics card has lasted for a year already, it will continue to work, provided you don't, like, break it by overvolting it or something. It will continue to work way beyond the point of it being viable to use. Like, PC technology moves very fast. So by the time that your graphics card would maybe fail just due to age of components, it's going to be so old that it's not relevant anymore anyway. So yeah, used GPUs, not a problem. Right, guys, it's been a fucking amazing stream. Thank you so much for jumping on and being part of it. I've had a great time. Gonna do some more of these, and yeah, I'll see you probably this week again some point in the evening for some more in-phase juice amplifier repairs. Let's get going. Have a great time, have a great rest of the evening, have a great sleep, and I will catch you all in the next one.